Good morning, ladies and gentlemen. My name is Volodymyr Artemchuk. I represent Puhu Institute for Modeling in Energy Engineering, where I currently work as a Deputy Director for Scientific and Organization Work. Welcome to the first International Conference of Sustainable Future, Environmental, Technological, Social, and Economic Matters. It's truly a pleasure to see many scientists, experts, and professionals who are dedicated to the shaping sustainable future for our planet. This conference serves as a platform for us to come together and delve into the pressure issues surrounding environmental sustainability, technological advancements, social responsibility, and economic consideration. Our goal is to foster mindful discussion and explore innovative solutions that can lead us toward a more stable and resilient future. Today, we have a privilege of hosting the Infrastructure, Resilience, and Sustainable Energy Workshop. The topic of our seminar is leading for our institute. This, in particular, is evidenced by the participation of our institute in the implementation of several international projects in this direction. For example, the first project is adaptive infrastructure recovery from repeated shocks throughout resilience stress testing in Ukraine. Is aimed at developing the science and resilience by developing the resilience recovery under attack framework. I am honored to be the principal investigation of this project from Ukraine. Another project I am also involved in called agnostic risk management for high impact, low probability events. Funded by the European Union, the Agile project is become an innovation in disaster risk management. And at our next workshop, I plan to highlight a separate topic dedicated to this problem. So, Ukrainian scientists, like its energy system, demonstrate their resilience every day. And shortly, we will probably become the most qualified specialist in the field of resilience. It's my serious hope that this discussion will inspire us to take action both individually and collectively towards a more sustainable energy future. Thank you, and let us begin the first international conference on sustainable future. But before we proceed, I would like to highlight a few important guidelines for this conference. This conference is international, and therefore all questions, response, and discussion are to be conducted in English. Next point, this will ensure effective communication and maximize the participant to attend from diverse backgrounds and different countries. Each presentation, including in subsequent discussion, is allotted a total of 15 minutes. We kindly request all speakers to adhere to this time limit to ensure a smooth flow of the conference. We have video recording for all the presentation except of presentation 25. So even power outage should not prevent us from hearing all the presentation. Thank you for your attention, and let us now begin with the first presentation.
Good afternoon, dear conference participants. Your attention is invited to work on the topic, electric drive of coordinated rotation.
Pardon, but I didn't hear you.
Conclusions in
Yes,
nearly
yes,
all
yes.
also,
Just a minute.
significant strategic documents. Notably, Good afternoon,
Okay.
dear conference participants. Your attention is invited to work on the topic, electric drive of coordinated rotation for mechanisms of flow transport systems. Presently, energy conservation stands as a primary focus of innovative development in the Ukraine and Republic of Kazakhstan, reflected in the inclusion of energy-saving initiatives in nearly all significant strategic documents. Notably, the industrial sector alone accounts for approximately 70% of total electricity consumption, with electric drives of flow transport systems, FTS, contributing an average of 20%. Flow transport systems typically consist of a series of conveyors, each designed for specific functions such as loading, transporting, sorting, and unloading. These conveyors may include belt conveyors, roller conveyors, screw conveyors, or pneumatic conveyors, depending on the nature of the materials being transported and the layout of the production facility. The frequency method stands out today as the most technically and economically viable control method for alternating current, AC, electric drives. Nevertheless, research indicates that frequency-controlled electromechanical systems utilizing stator circuits, while offering extensive functionalities, pose a technically more intricate challenge for voltage-frequency regulation compared to regulation through rotor circuits. This complexity arises from the fact that the power of a thyristor frequency converter, TFC, is comparable to that of electric motors. Consequently, the advancement of novel circuit solutions for regulating the performance of FTS emerges as a pressing task within contemporary electromechanics. This study aims to design a two-motor electric drive for the mechanisms of flow transport systems with medium to high power, aiming for improved energy efficiency. Slide 4 illustrates a functional schematic of a dual-motor electric drive coordinated rotation featuring a cascade arrangement of two asynchronous motors. In this configuration, the rotor windings of the asynchronous motors are linked in series via a controlled rectifier within the rotor circuit of the first motor and an inverter within the rotor circuit of the second motor, collectively referred to as a thyristor frequency converter. For investigating the dynamic characteristics of the coordinated rotation electromechanical system in flow transport system mechanisms, we conduct computer simulations of a two-motor electric drive setup. This configuration comprises two asynchronous motors with wound rotors, with one motor connected via an asynchronous valve cascade circuit and the other connected through a dual-fed machine circuit. Slide 5 shows a simulation model of a two-motor electric drive corresponding to the functional diagram shown in Slide 4. Computer simulation of a dual-motor electric drive was carried out in the MATLAB system. Dynamic characteristics of a two-motor electric drive obtained at various values beta, opening angles of the thyristors of the rectifier group, are shown in Slide 6. Examination of the dynamic traits reveals a distinction between the second motor, linked via the dual power circuit, and the first motor, connected through the valve cascade circuit. Despite identical parameters in the equivalent circuits of both motors, the sliding power directed to the rotor windings of the second asynchronous motor proves inadequate to replicate the characteristics of the first motor. Consequently, an additional power source in the rectified current circuit of the motor rotor is deemed necessary. A functional diagram of a two-motor electric drive with an additional power source in the rectified current circuit of the rotors of two asynchronous motors is shown in Slide 7. Slide 8 illustrates dynamic characteristics of a two-motor electric drive at beta equals 30 degrees and beta equals 60 degrees respectively. As can be seen from the last slides 8. After connecting an additional power source to the rectified rotor current circuit, the dynamic characteristics of the two motors coincide. Thus, during the work, the following conclusions were made. Therefore, employing a cascade circuit in a dual-motor electric drive, supplemented by an additional power source in the rectified rotor current circuit, enables the synchronized rotation of two motors. This synchronization can be achieved not only with identical nominal parameters but also with differing power and synchronous frequency of rotation. The primary advantages of this approach to coordinated rotation in a twin-motor electric drive using a cascade scheme include the capacity to adjust the power factor of the machines. Moreover, it reduces the power transferred to the control circuit by the thyristor frequency converter, thus enhancing the reliability of the electric drive's power components. By regulating the rotation frequency of two AC motors, it becomes feasible to enhance energy efficiency. Thank you for your attention.
Thank you for the presentation, dear colleagues. Do you have any question? If nobody have question, I will start. Waldemar, can you elaborate the main advantages of using a cascade circuit in a dual motor electric drive for flow transport systems compared to the traditional single motor drives?
Thank you for your question. Dear colleague, I'm Vladimir Kamenko. Let me explain these main advantages. The electric drive of connected rotation has a number of advantages for mechanisms in flow transport systems. First of all, its efficiency. Connected rotation ensures smooth operation and better energy efficiency. By precisely controlling the rotation of multiple components, you can minimize energy loss through friction and unnecessary movements. Second is synchronization. In streaming system, it is extremely important as the different components work together. Coordinated rotation ensures the different parts of the system moving sync, reducing the risk of congestion of interruptions in flow. Third advantages is precise control. Electric actuators provide precise control of rotation speed and torque, which is important in flow conveyance system where precision is paramount. Next, I think it's flexibility. Electric actuators can be easily programmed and adjusted to suit different costs, products type, and process requirements. This flexibility is especially valuable in systems that need to work with changed conditions on production schedules. No, and of course, it's integration with automation because coordinated rotation electric drive can be easily integrated into automated systems, providing greater efficiency and productivity. Overall, the use of coordinated rotation electric drive in flow conveying systems provides provides improved efficiency, accuracy, flexibility, and safety, ultimately leading to increased productivity of low operation costs. Thank you.
Thank you, Vladimir.
I have one question.
Yes, please.
Could you ask me a few words about the reliability of the system?
Reliability, do you mean reliability of flow transport system or flow transport conveyors?
Yes. We use dual models, as I understand of you. And what about reliability?
Yes, we use dual motors.
Okay, thank you very much. I understand that reliability is didn't increase. Okay, so.
Dear colleagues, any other question?
Thank you very much.
I have one more question. How does the inclusion of an additional power source in the rectified rotor current circuit contribute to the synchronization and efficiency of the two-motor system?
Yes, thank you. In order to analyze the efficiency of this system, first of all, we in our work we discussed economic efficiency, and we analyzed next consideration. The frequency regulated two-motor electric drive, the motor electric drive on the basis of dual power machine, and third, it was a two-motor electric drive based on an asynchronic valve cascade and a double feed machine. Comparative analysis these systems by cost and weight and size indicator showed that the cost our system, according to the scheme, is significantly cheaper in the entire power range compared with other systems, and is not inferior in terms of weight and size indicators.
Thank you, Vladimir. We must move to the next presentation.
Thank you, dear friends. Thank you.
And I share the next presentation. 1 minute.
Good afternoon, dear colleagues. My name is Dr. Oleg Lisak, and I am a scientific researcher at the Geothermal Energy Department of the Institute of Renewable Energy of the National Academy of Sciences of Ukraine. Today, I would like to present my research on the topic Analysis of the current state and future prospects of renewable energy in heating and cooling systems in Ukraine. First, let's consider two important documents, the Paris Climate Agreement and the European Green Deal. The European Green Deal, presented in 2019 by the European Commission, aims to achieve climate neutrality for the EU by 2050. Good afternoon, dear colleagues. My name is Dr. Oletel Sak, and I am a scientific researcher at the Geothermal Energy Department of the Institute of Renewable Energy of the National Academy of Sciences of Ukraine. Today, I would like to present my research on the topic Analysis of the current state and future prospects of renewable energy in heating and cooling systems in Ukraine. First, let's consider two important documents, the Paris Climate Agreement and the European Green Deal. The European Green Deal, presented in 2019 by the European Commission, aims to achieve climate neutrality for the EU by 2050. Any new member of the EU, including Ukraine, is expected to align with this policy. This makes it crucial for Ukraine to adopt similar initiatives. Climate neutrality, generally defined as achieving net zero emissions of all greenhouse gases or solely carbon dioxide, involves balancing emissions with their removal from the atmosphere over a specific period. According to the International Energy Agency (IEA) annual report for 2023, further progress is required to meet the 2050 net zero emissions goal. The year highlights a lack of state regulation and clear goals as major obstacles for achieving this target. This scenario aims to limit the temperature increase to 1.5 Celsius degree above the pre-industrial level as outlined in Paris Climate Agreement. When we talk about the green energy transition in energy supply, we focus on three main areas: electricity, heating and cooling demands, and transport. Historically, most attention has been given to electricity generation. However, it is important to note that heating and cooling accounts for almost 50% of the EU's total gross final energy consumption. This highlights the critical role that renewable heating and cooling must play in our efforts to transition to a sustainable energy system. We need to give this sector the attention it deserves to meet our climate goals. Let's take a closer look at the share of renewable energy used for heating and cooling Ukraine compared to the European Union and its member states. From the data, we can observe several key points. First, Ukraine's share of renewable energy for heating and cooling is almost 2.5 times lower than the EU's average share. Second, interestingly, Ukraine's share is higher than that of three EU member countries, Belgium, the Netherlands, and Ireland. Third, when we look at the three largest economies in the EU, we see that Germany and Italy have shares below the EU average. France, on the other hand, has a share that is only slightly higher than EU average. This comparison highlights the varying levels of renewable energy adoption across different countries and underlines the significant potential for improvement in Ukraine's renewable heating and cooling sector to meet or exceed the EU average. While there has been a notable increase in the amount of heating and cooling energy generated in Ukraine from 2014 to 2020, this increase is predominantly attributed to biomass, specifically solid biomass. The contribution of heat pumps to heating and cooling energy is also noteworthy but remains marginal. It's important to highlight that no geothermal heating and cooling other than that from heat pumps is generated. Additionally, the amount of energy generated from solar energy is negligible in comparison. On this slide, we can observe the share of biomass in heating and cooling for Ukraine in relation to the total share of renewable energy in heating and cooling, expressed as percentages. Throughout the period analyzed, other renewable sources besides biomass did not exceed 2.5% of the total share. This indicates a pressing need to diversify the sources of renewable energy in heating and cooling in Ukraine. This slide offers deep insight into the share of biomass in the heating and cooling of private households in Ukraine, related to the total share of biomass in the heating sector. Over the period from 2014 to 2020, biomass consumption by heating and cooling was primarily attributed to private households. However, there has been a noticeable decrease in the share of biomass consumption by private households, dropping from almost 3/4 to 2/3 of the total consumption. This slide provides insight into the share of different types of heat pumps based on the amount of heat they generate. It is notable that while there are 3 types of heat pumps in Ukraine, scientific literature often analyzes just 2: air-source heat pumps, equivalent to aerothermal heat pumps, and ground-source heat pumps, equivalent to geothermal heat pumps. Third-type hydrothermal heat pumps can be considered as a part of ground-source heat pumps. Air-source heat pumps have the highest share, largely due to their ease of installation and widespread use. This slide introduces the concept of the levelized cost of heat for heat pumps, a critical metric for assessing the cost-effectiveness of heating systems. The equation provided illustrates how LCOH is calculated, considering factors such as capital expenditure, operation and maintenance cost, fuel expenses, carbon taxes, and the discount rate over the system's lifespan. It is important to note that for heat pumps to be considered an economically viable option, they should demonstrate better cost effectiveness compared to conventional heating systems that rely on fossil fuels. The recent surge in fossil fuel prices, driven by the full-scale Russian invasion against Ukraine, has significantly increased the cost of conventional heating fuels. This increase in fossil fuel price has made heat pumps a more economically viable and attractive alternative for heating purposes. This slide highlights the significant impact of the full-scale Russian invasion against Ukraine on the growth rate of the heat pump market. According to a report from the European Heat Pump Association, annual sales of heat pumps in 15 European countries surged by 37% in 2022 compared to 2021. However, this growth was followed by a 5% decrease in 2023 compared to 2022. Several factors contributed to this decrease. Firstly, the stabilization of energy prices in Europe may have influenced consumer decisions. Additionally, some consumers may have postponed their purchases in 2023 to take advantage of expected higher subsidies in 2024. Furthermore, the removal of government subsidies in certain countries could have also played a role in the decline in sales. Overall, these trends underscore the sensitivity of the heat pump market to external factors and the importance of government policies and incentives in driving market growth. There are several key insights emerged regarding the state of renewable energy in heating and cooling systems in Ukraine. First, renewable energy share. In 2020, Ukraine's share of renewable energy in heating and cooling stood significantly lower than the EU average. This highlights the need for further efforts to increase the adoption of renewable energy sources in Ukraine's heating and cooling sector. Second, biomass utilization. The data shows that biomass is a primary renewable energy source for heating in Ukraine, so there is a need to diversify options for renewable heating in Ukraine. Third, heat pumps. While the current share of heat pumps in renewable heating and cooling is relatively small, there is expectation for growth in this area. However, to ensure the accuracy of forecast models, they must closely align with actual market conditions. In conclusion, these insights underscore the need for Ukraine to accelerate its transition towards renewable energy sources in heating and cooling. This transition not only aligns with global efforts to combat climate change, but also presents an opportunity for Ukraine to enhance its energy security and promote sustainable development. Thank you for your attention. If you have any further questions or would like to discuss any aspects of this research, please don't hesitate to contact me as shown in email.
Hello everyone, my name.
Thank you, Oleg, for the presentation. Dear colleagues, have you any question?
I have one.
Yes, please.
You consider the heating and cooling power system separately from another part of energy needs for economy, for industry, and so on. And it is well known that now the heating and cooling system, sorry, not system, but consumption different in different seasons. In winter and in summer, the need of cooling and heating value different significantly. So now the system working together, not only separately. I mean that cooling system must working together with electricity system, because the demand of electricity in winter significantly bigger than in summer. And the same situation in cooling and heating system and consumption of the production of this producing by the system. What do you think about necessity to consider the renewable cooling and heating system together with the development of electricity system and not separately as you presented? Thank you.
Thank you very much for your question. It is a rather good question, and I would add that when I was working on my thesis, I was asked to do some additions to my thesis. And when I looked through different scientific literature, there was a rather interesting investigation which was dedicated to the future use of heat pumps for the United Kingdom, for Great Britain. And in this investigation, the author analyzed how much an electrical energy would be consumed if the share of heat pumps rose in his country. So you're totally right that there is a need to investigate that question, but in most literature sources, it's actually thought without that thing. Also, I would add to another your rather important remark. I would like to point out that you are rather right that we should think, because like currently we have heating in winter, like we in Europe, and cooling in summer, but due to a climate change in some cases, there is a need. We need to spend less energy on heating in winter and more energy in cooling in summer. And there are some kind of systems like known, for example, there's aqua-fired thermal energy storage systems, which actually can works better if there is, let's say, almost equal quantity of energy which we use in summer and winter respectively. So yes, your remarks are totally right that this aspect should be paid much more attention, and I would like to implement that in my later stages of this work. And speaking one more important thing, at this time, whenever we speak about statistics on heat pumps and their use, we usually think of direct working systems without, let's say, any long-term storage. But in some countries, like for example Denmark, there is a thing known as seasonal thermal energy storage. In such systems, while they can be described as geothermals and there could be installed heat pump, they, for example, can use extra heat stored in summer and then use it for heating in winter. And respectively, there could be created systems which store some cool storage material in winter and then use it in summer. So there is a lot of things how that work can be wider. That's it.
Mm-hmm. Thank you.
Thank you very much.
Dear colleagues, any other question? I have one question. In your analysis, what role do biomass and heat pumps play in the future energy landscape of Ukraine? And how do their own environmental impacts compare?
Thank you very much for your question. When I was writing this work, I paid attention that really depended on the source, the, let's say, a bit contradictory views. Or from one point of view, biomass can be counted as totally green energy source. Other pointed out that it all depends on the way of how we calculate greenhouse gas emissions from biomass and how we should utilize it, because there are many other possible ways to utilize it rather than directly burning. And as is rightly to be said, we can burn that biomass, but to generate, for example, electricity. But in the context of heating and cooling, burning biomass definitely can't help us with the cooling part. So speaking about biomass, I would say that due to the recent topic, for example, of my institute, it cooperates with a Swedish Environmental Institute. It's one of the Swedish organizations in the field of sustainable energy development. And Sweden is the leading country, as you have seen, in using renewable heating and cooling, mostly thanks to the use of biomass. And so the trend currently is to limit the use of biomass and to pay more attention to heat pumps, with the possible decrease of the biomass output and maybe changing its use for other topics, like for other than heating and cooling. Like for example, I have recently read works on how biomass can be used to produce green hydrogen, like that. And so that's the scope of it.
Thank you for your answer.
Thank you.
Dear colleagues, do you have any questions?
I have comments to the last question.
Yeah, please.
It is well known that the influence of biomass on the environment is neutrality, because the growth and any kind of the agriculture products using as biomass, they have positive and negative influence on the environment. And when we estimate the results of this environment, it is well known that it is zero influence on the environment. Thank you.
Thank you very much.
Thank you for your comments. And dear colleagues, we must move for the next presentation.
I'm going to talk about modeling of cone crusher steady-state operation modes. Energy efficiency is a key factor that ensures favorable conditions for the recovery and further sustainable development of Ukraine. At the same time, mining and mineral processing plays a key role due to its high power intensity. Analyzing the energy component of mining production cost per individual processing stage, it can be found that the highest energy consumption has crushing and grinding processes. Therefore, energy efficiency growing can be achieved by improving these operations. There are two possible ways to do this. The first is the complete re-equipment of production lines with the latest equipment with high level of energy and efficiency. The second is to improve existing equipment and automated control procedures. The last way is more economically feasible, as it does not require large investment. At the same time, it's implemented if it's possible to identify reserves for improving energy efficiency. This is achieved by studying the steady-state operation modes of technological equipment. The purpose of this article is to obtain mathematical models of cone crushing steady-state operation modes, which can be used in the development of a control system for technological unit to determine the reserve for increasing energy efficiency, as well as its operating point and the limits of change in the main technological parameters. As a target of study of the steady-state properties of crushers, I choose a cone crusher with mantle width 2200 mm. The main purpose of the cone crusher is to reduce the lumpy material to the required size. Therefore, the main process variables that are controlled are product capacity and particle size distribution. There are a lot of input and output variables to control the crusher. The connection between them is shown in the function diagram of the unit. The input variables are feed capacity, the closed side setting, CSS, and the eccentric revolution speed. The disturbance is represented by a set of parameters that characterize the properties of the O. Percentage of the control particle size, hardness, fracture, moisture, etc. The output variables are product capacity, electric drive power, the wear of lining plates, and the amount of ore in the crusher. For the limited period of time, the steady-state model of the relationship between feed capacity and product capacity can be represented by linear dependence. The figures in slides show that as the ore hardness increases, if the feed is constant, the crusher product capacity decreases. Similarly, the CSS affects product capacity. Increasing or decreasing in the CSS leads to an increase or decrease in product capacity respectively. Next, we will consider the crusher steady-state model of the relationship between the feed capacity and electric drive power. Taking into account the closed side setting, it was determined that the power consumed by the cone crusher electric drive in the operation range increases with increasing feed capacity. It was found that the power consumption has a nonlinear dependence on the crusher product capacity for different values of the closed side setting. The steady-state characteristics based on equations from previous slide for the typical CSS values 5, 10 and 15 mm are shown in figures. At low feed capacity, the power consumption decreases with increasing closed side setting. Thus, the required product capacity can be achieved under any expected conditions. The next slide presents steady-state model for the relationship between product capacity and percentage of particle size class plus 20 mm for certain closed side setting values. The percentage of particle size class plus 20 mm as a function of crusher product capacity is shown in figures. The steady-state characteristics plotted according to equations from previous slide for typical CSS values are shown in figures. With increasing product capacity, the percentage of particle size class plus 20 mm decreases. When the crusher product capacity is constant, the percentage of particle size class plus 20 mm is growing according to increasing CSS. The graphs also shows that at a low crusher capacity of the 310 ton per house, it's impossible to ensure the specified quality of the product. The influence of CSS on the percentage of particle size class is not as significant as product capacity, so adjusting CSS in range 5 to 10 mm can provide an acceptable crushed ore size when the product capacity change in the range from 320 to 330 ton per hour. At capacity above 330 30 tons per hour, the particle size distribution can be controlled by varying CSS in the full range, from 5 to 50 millimeters. During the operation of the crusher, the liners of the concave and mantle and other elements wear out. The wear of the liners is essential to the product particle size distribution and power consumption. Equation 3 and figure A shows the dependence of the amount of crushed ore over the service life of the chamber liners depending on the product capacity on the intensity of mineral processing. The graph shows that with the increasing product capacity, the amount of crushed material increases during the period between lining replacements. When using magnesium steel lining, it can be assumed that with an increase in crusher product capacity, liner wear increase within the specified limits. This shows figure B. Proposed the mathematical description for analyzing the cone crusher steady-state operation modes based on experimental data from various sources. Multidimensional regression dependencies are determined, which allow us to establish the regularities of the iron ore crushing process. The input variables are the feed capacity and closed site setting. The output variables characterizing the quality of the process are product capacity, electric die power as a percentage of particle size class plus 20 millimeters. The model can be used to develop a cone crusher control system to determine the reserve for increasing energy efficiency, as well its operation point and the limits for changing the main process parameters. Thank you for your attention.
Hello, dear colleagues.
Thank you for your presentation, dear colleagues. Do you have any question?
I have some.
Yeah, please.
What methods and algorithms we use in order to get regression equations?
Hello, dear colleagues. Thank you for your question. For obtaining regression models, I used mean square error, mean square error methods, which I obtained using experimental data from different sources. But the main method is метод найменших квадратів, якщо українською мовою.
Yes. And can you try to estimate the significance of the coefficients you are getting from these methods? I mean, the standard deviation of these coefficients and how I have believed in these coefficients. Maybe these coefficients consist significant value of errors. How you prove these equations? How you estimate the correct of these equations?
Estimation of coefficients, mean square error is K error for estimate this regression.
Mean square errors when you try to minimize only is a rule or algorithm how to calculate these coefficients only. And when you calculate this coefficient, you must to formulate the next question. What is the errors consist of each coefficient in this equation? This equation is approximately of the real data, approximately. And how you estimate the approximation error of these regression equations is a fundamental question of the statistical theory. Thank you.
Yes, I understand the question. This is a question about adequacy, fitting efficiency of this model. Fitting equations, I can obtain it by compare regression dependencies and real data.
Mm-hmm. And the next question, do you recommend this approach to another fields of the driving, maybe motors, diesel, not only electricity system?
This approach, if we have data, we can use this method to obtain steady state models. But these regression dependencies, which I have in this research, they only can used for control contrast, only contrasters.
Mm-hmm. Thank you.
Thank you for your discussion. And now we must move for the next presentation.
Hello, dear colleagues. My name is Daniil Filipenko. And today I want to introduce you the automated system of the trolleybus park as the part of sustainable city infrastructure. The comfort of living in a particular city largely depends on its transportation infrastructure. Trolleybuses play a crucial role in providing fast, environmentally friendly and convenient transportation for city residents. Modern and comprehensive trolleybus system can contribute to reducing the car traffic, decreasing congestion, and improving air quality in the city. A well-developed trolleybus network significantly facilitates the daily commuting of the residents. The subject of research in this work was the system for monitoring the technical condition of the trolleybus. Trolleybus consists of numerous of systems that should work properly in conjunction. Sensors attached to these systems collect the data and pass it to the monitoring system. The core system and the heart of all types of trolleybuses is electric motor. The electric motor operates on electrical energy supplied by the power supply system. In this research we focused on battery parameters monitoring. Battery belongs to power supply system. The main parameters of the trolleybus battery are voltage charge and the temperature. Consistent monitoring of these parameters helps to keep the trolleybus in normal technical state and therefore improves the city infrastructure quality. Let's look to look on system architecture. The system consists of three main components that communicate with each other using the HTTPS protocol, web interface, web server, and a multitude of trolleybuses in the trolleybus fleet with installed controllers and sensors. The web interface is presented as a regular website on the internet, essentially serving as the terminal for interacting with the monitoring system. The primary advantage of such a web interface is accessibility. Trolleybus operators can access it from any device with internet access. The web server operates as a REST IP service, meaning it can receive and respond to HTTP requests. The web server receives data from sensors and as well as information inputted by the users through the web interface. The controller is installed on each trolleybus in the fleet and serves for processing and transmitting the data from the trolleybus to the monitoring system. The data is received by the server and through the HTTP request. For the server, it doesn't matter which modem or controller is used to send the data. Therefore, if technical specialists of the trolleybus fleet will decide to replace the modems on trolleybuses, the end user will not be aware of such changes and no changes to the system source code will be necessary. Let's look precisely on the actual system. The main page of the system is interactive dashboard. Interactive dashboard is represented by a list of
It is something else with presentation.
Yes, some trouble with electricity. Just a moment.
Pardon.
presented by list of cards of trolleybuses. Each trolleybus is represented with nice colored image. Color of this image means the technical state of trolleybus. For example, if the color is green, then all is good with trolleybus state. If the color is yellow, then trolleybus has minor faults or minor breakdowns. If the color is red, then the trolleybus is in a critical state and it should be immediately repaired before next ride. Also, there you can see the side number of trolleybus and two nice indicators. First indicators indicates the signal if the trolleybus is online, if the data can be received from trolleybus, and the second one represents the voltage. It means it defines if the voltage is in acceptable range. If you will click on trolleybus card, you will get redirected to the trolleybus details page. On this trolleybus details page, the sensors data is displayed for the current date. The sensors data consist of voltage charge and temperature. Its data is received from the sensors, and some calculations are done on the server side, and this information gets displayed to the end user. From this page, you can also redirect to the touch state page and to the touch acts page. Let's look on touch acts page. Touch act is like formalizing way to store, to describe to represent the trolleybus touch state. It's like just a document with information about current tech state. On the checked page, you can see the list of the checks of the particular trolleybus. Here you can search them by type, by date. Users also can create the checks and also can attach the sensors data from trolleybus to the checks, which make this functionality very convenient for the employees of trolleybus fleet. Each checked can be viewed, can be deleted, and can be exported to PDF. Next page is trolleybus tech state page. It is used for managing and monitoring the tech state of trolleybus. Here you can see two tables, but there is actually three tables. First table represents the current faults of trolleybus. You can register faults, and tech state will be tech state depends on these faults. For example, if you will register the critical tech fault, then the trolleybus will become red. If also you can repair the fault, and trolleybus will become green again. State will be normal. The second table is the history of repaired faults, and the third table it is not displayed on this screenshot, but it exists. The third table lists the alerts of trolleybus. Alert is like messages that get received from trolleybus. For example, if the voltage is out of range, then the alert with corresponding message will appear in this table. Next page is admin panel. Admin panel is a page where admins can manage the system. In system there is three types of users: admins, writers, and viewers. Admins can create the other users and manage them, and also admins can adjust the system parameters. For example, for now there is only one system parameter, system parameter of acceptable range of voltage charge, but in future we will add more system parameters. So this was the presentation and short overview of the trolleybus system. Such developed system represents only the first step in optimizing the operation of entire trolleybus fleet, and the system application significantly enhances the productivity of trolleybus park engineers and employees, and makes city infrastructure more convenient for citizens. So thanks for your attention. I'm ready for your question.
Thank you for your presentation, dear colleagues. One short question and we must move for the next presentation. But we have chat for the discussion. Who have one short question? No question. Thank you for the presentation, and now we must move for the next presentation. Let's start.
Hello everyone, my name is Olena Rubanenko, and I want to present you our research entitled Study of Double Short Circuits on Earth in 10 kV power grids with isolated neutral and with high-level penetration renewable energy sources. Our team consists from 4 people who work in this project: me, Olena Rubanenko, Milana Belika, Chief of Department Ecology and Environmental, University of West Bohemia, and Professor Rubanenko, and Associate Professor Inna Vishte from Vinnytsia National Technical University. So, our project consists from 4 types. It is introduction, importance of distributed sources of generation in times in war, analysis of 10 kV network damage data, and analysis and presented simulation of the mode of a 3-phase 110 and 10 kV network in MATLAB. So, just want to maybe remind you how work our equipment, and if you speak about new equipment, similarly we must know that some infant period exists. We speak about a lot right now, a lot of useful life, and also try to control it our equipment in this time. So failure rate in this time not so big, but we have also problem in the C part, in this wear out, because our power grid, how it's noted in a report in 2021 years, and probably in war times it is not start to be better, so it is wear out time. In this reality, we must analyze this work in our power grids. So, the analysis of damage and experience of operation 635 kilovolt networks allows us to make the following conclusion. First, so we must eliminate places with weakened insulation as an aging process. It is a requirement perfectly work disconnection, and also we must have possibility to disconnect what network elements. Second, a significant share of damage in network is damage to support and through insulators and switching devices. Specific damage of switching devices from internal overvoltage is quite high and only 3 times lower from lighting overvoltage. So, in this case, important also to speak about important distributed sources of generation in times of war. So, if to take into account condition our transmission lines and that a lot of attacks we have in the centralized power sources, for example, heating power plants, condensing power plants, hydropower plants. In this case, the green energy market is developed rapidly because more and more people understand and want to pass on our world to their descendants in the least good of condition as we receive from our parents, and a lot of owners start to install the distributed power sources. Also, in an interview with Chief of Winds Obelenergo, Yuri Kasic was noted that distributed power sources also to propose us some energy efficiency and energy safety, because it's stupidly to try attack a lot of shared power sources. It is more expensive than to attack just big power station. Okay, so but it is not really to say that distributed power sources also not damaged a lot of, but this damage not can to be so crucial for power grids or power system like big centralized power station. The lower the voltage class of power lines or substation, the greater their number. So it's less known to the aggressor. It's not possible to note it and understand to allocate a lot of them. But if you analyze of 10 kilovolt network damage data, it's necessary to classify it in 2 types. First, in overhead network, second in the cable network. Damage to line poles, overlapping could damage to insulation on poles, damage to cable coupling during the transition of overhead lines to cable lanes. It is everything more popular for overhead network. For cable network, damage to insulation of substation, damage to terminal and connection coupling, damage during excavation work in the vicinity of cable row, damage to cables, and so on. For one case in the wartime, overhead network is more can be more damaged, but also in cable network it's more difficult to understand and find place where it's damaged, and they're also quite old and not change a lot of times. In this slide you can see diagrams of damage to power lines with voltage 6 and 10 kV. So how you can to see in the one phase and one phase in the grid, it's more popular. And the most frequent types of internal overvoltage in 635 kV networks is overvoltage associated with single-phase earth faults, accounting for up to 80% of all. So in this slide, next slide, you can see what schemes we want to present it. It is current oscillogram obtained using scope. We work with really very easy and similar schemes. You can see 3 load in different loads, so it's unsymmetry, and Q1, Q2, Q3, it is breakers what we can to control our equipment and to save. Okay, the calculated values of the maximum current protection setting for phase A of the first lines, phase B of the second lines, and for the input switch. And also in the next slide we see how it's work, because all this result is modeling and simulating not real grid, but in simulated grid in MATLAB, which simulated in Simulink, but use real distance, real location, and so on. These graphs show what value of the delay time in the operation of the recloses should be set. Take into account the time of the selectivity degree to ensure error-free operation of the protection and so on. The time selectivity degree of the recloses takes into account the operating time of the circuit breakers and the error of the time relays. According to the graph, the delay time in our case it is 0.05 seconds, and the transient process end and steady state short circuit mode begin. So in this case, we must to understand and calculate where really must to start our relay protection, how it's calculated, and how correctly to design relay protection. A lot of other software possible use, not just Simulink MATLAB, but if we want to more precisely see and try to simulate mode, in this case, Simulink MATLAB give us a huge instrument and huge device. So, based on the result of calculation of the parameters of 10 kV power transmission lines considered in the work, it is determining that the tripping current is equal 300 ampere, and the power supply action on the input switch on the substation to which the 10 kilovolt power lines is connected is equal 1323 amperes. So obtained model can to help us to recalculate similar schemes and give us possibility to design our grid with take to account high penetration renewable energy sources. Thank you for your attention. If you have any question, you can write an email or to give me directly.
Thank you, Elena, for your presentation. Dear colleague, do you have any question?
I have one.
Yeah, please.
Working with model, how you can where you get the data of the or value of the parameters in this model?
Okay, so we use Simulink model, and we have a little power distributed power grid. It is Vinnytsia Oblenergo 0.6, 0.4 kilovolt, and we try really use the resistance, no, all characteristic what's really used in traditional grid. But what problem we have? It's not so easy. Simulink model. It is American adapted in our condition. Also, we have similar problem with power factory model. Try to adopt because they have equipment not corresponding with post-Soviet Union country. And maybe more detail about this model also can give explanation Professor Urbanenko. I just to translate. Олександр Євгенійович, тут питання в тому, що яким чином ми задавали параметри в нашу про нашу схему.
Especially when in the situation of destroyed of the electricity system.
Особливо в той момент, коли в нас відбувається пошкодження електричних мереж.
Я українською. Доброго дня всім, і я українською мовою. Зверніть увагу, що використовувались дані параметри мереж Вінницяобленерго, також Хмельницькобленерго і Тернопільобленерго. І, на жаль, найбільш розповсюджений захист, максимальний струмовий захист цих мереж інколи працює неселективно, що призводить до збільшення кількості недопостачання електричної енергії за рахунок неселективної дії максимально струмового захисту, який є основним в цих мережах. На жаль, захист працює нестабільно, ненадійно, а в більшості випадків працює надійно, однак за певних параметрів мережі в цих фактично 4 обленерго чи Чернівці обленерго існують такі лінії, де досить часто цей захист не працює. І тому потрібно було пояснення ось таких позапланових відключень. І як результат для саме тих випадків запропоновано було збільшити час на застосування захистів, що є невиправданим з одного боку, тому що призводить до пошкоджень суміжних ділянок. Однак на сьогодні поки що тимчасово прийнято рішення. У мене все.
Should I translate?
Yes, shortly, please.
Okay, so just a few words. In this research, we take into account for power supply company Вінниця, Хмельницький, Чернівці, and Житомир. Ternopil. And when we have a lot of destroyed power grids, we sometimes relay protection don't work correctly, and we must exactly to explain and to try to account this destroyed and to give in our relay protection correct input parameters for correct works. Я правильно переклала?
Thank you.
Thank you so much for the attention and question.
Thank you, colleagues, for the interesting discussion. And now we must move for the next presentation.
Hello, colleagues. My name is Ihar Butko. I want to introduce you our presentation, Vegetation Zone Segmentation in Multispectral Imagery. Semantic segmentation of images using convolutional neural networks allows for the assessment of vegetation areas in multispectral images with high resolution. To improve classification accuracy, multispectral images utilized providing additional information for each pixel by supplementing color images with near-infrared channels. These channels contribute to clearer class separation and aid in distinguishing classes with similar visual characteristics, such as assigning a specified green pixel to classes like grass, shrubs, or trees. The issue of the versatility of the models used in practice is important. This paper shows the possibility of using UNet-shaped architecture network, which is trained on a data set with aerial images to find vegetation zone in satellite images. For the validation of result obtained through semantic segmentation, it's essential to obtain a reliable assessment of vegetation cover area independently. To achieve this, the normal difference vegetation index, NDVI, proposed as a suitable metric. NDVI is a simple quantitative indicator of the amount of photosynthetically active biomass, commonly referred to as a vegetation index. The aim of the investigation is to consider the implementation of a semantic segmentation of 4-channel multispectral images using a UNet-shaped network and to access the quality of segmentation of the vegetation zone using the calculation of the NDVI. As mentioned in original papers, the main idea of the UNet architecture is to supplement a conventional convolutional network with a symmetrical path, where the pooling operations dimensionally reduction of objects are accordingly replaced by dimensionally increment operator that allowed increasing the resolution of the output. In the part in which there is an increase in dimensionality, there are many future channels that allow the network to spread contextually information to layers of high resolution. Therefore, the part in which the explanation occurs in symmetrical to the part of the construction, this gives a U-shaped architecture. Such a network uses only convolutions without any fully connected layers. To predict the value of pixels within an image's area, the missing context is extrapolated by additional processing, which look like a reflection from the point of view of network symmetry of the input image. This tiling strategy is important to imply the network to large images, as otherwise the resolution will be limited. The classic network architecture is shown in figure in this slide. In our investigation, we proposed expanding the number of layers in the UNet network to 58, while maintaining the same architecture. This modification enabled achieving satisfactory results for 4-channel near-infrared plus RGB images instead of requiring 6 channels, 3 near-infrared plus RGB images. In this picture, you can see images from the standard Hamlin Beach State Park dataset are shown in this slide. On the left is an images. On the left is an image used for training, and on the right side is an images used for validation. Given the primary objective is vegetation detection, segmentation into 4 classes is employed. There are: first, it's water; second, it's vegetation; third is soil; and fourth is other. The result of semantic segmentation are shown in this slide. The sequence of images displayed processes as follows. First, the ground truth images is shown. Next, an aerial images with 6 channel is presented. And finally, an aerial images with 4th channel is displayed. Now let's define the standard segmentation quality metrics. First metric is global accuracy, is a ratio of correctly classified pixel, regardless of class, to the total number of pixel. It's used in case where a quick and inexpensive estimate to percentage of correctly classified pixel is required. The second is mean accuracy. Mean accuracy is the average of the accuracy score for all classes in all images, with accuracy indicating the percentage of a correctly identified pixel for each class. Used when you want to read how correctly each class defines pixels. The third metric is the mean IOU, average instruction to union ratio. The average IOU value for all classes in all images. Fourth weight IOU, weighted intersection to union ratio, is the average IOU value of each class, weighted by the number of pixels in that class. This metric is used if images have disproportionately large classes to reduce the impact of small class errors on the overall quality score. And the fifth mean BF score, BFC, is the average of the BF score for all channel in all images. Comparative results of segmentation quality for 6th channel and 4th channel images are shown in the table. The results of segmentation of 4th channel images are expected to be slightly worse than the result of 6th channel images, but are quite acceptable for vegetation zone selection tasks. For additional experiments, 4-channel satellite images of the region near Yanakievo Donetsk region, denoted as fragment 1st and fragment 2nd, were employed. A map of the area with marked area of interest is shown in this slide. Note that the satellite image is fed to the network input without any pre-processing, so as not to change its statistic in relation to the images from the dataset that were used for post-training of the network. Result of processing for fragment 1 image are shown in this slide. The images are arranged from left to right as follows. In the original image, the label image, vegetation zone selected based on the vegetation class, and the selection of vegetation zone using binarizate NDVI. A result of processing for the for fragment per second image are shown in this slide. We have demonstrated the process of semantic segmentation using a UNet-like network. Illustrate through the processing of both 6-channel aerial images and 4-channel multispectral satellite images. While the segmentation results of 4-channel images are anticipated to be slightly inferior to those of 6-channel images, they are deemed acceptable for vegetation zone selection tasks. Moreover, utilizing 4-channel images, notable reduced processing time. Of particular interest is ability to train the model with aerial images database, allowing its application to satellite images. The quality of vegetation zone segmentation was evaluated in comparison with the normalized difference vegetation index NDVI. Through analysis, the result obtained, a strong correspondence was observed between the outcomes of semantic segmentation via neural network and NDVI usage. Thank you for your attention, and glory to Ukraine.
Thank you for your presentation. Dear colleagues, do you have any question? If nobody have question, I have a little question. How does the modified UNet convolution neural network architecture improve the accuracy of the vegetation segmentation in multispectral imagery compared to traditional methods like NDVI?
Okay, thank you for your question. My name is Alexander Mukovichuk. I would like to answer. First of all, I would like to say that the aim of our study is to verify two statements. The first one is whether we can use a classical UNet-like convolutional neural network trained on aerial imagery. And the second one is the usage of the NDVI for segmentation of the vegetation zones. And as we showed in our study, the both methods are in very good agreement. We can say that the results have an independent validation.
Thank you for your answer. Dear colleagues, do you have any question? If nobody have a question, I have one a little question. Can you explain the significance of using 4-channel image instead of 6-channel image in your study?
Okay, thank you. Our study was based on original paper by Kemker and co-authors. They used 4-channel images, and they gave us ground truth results to compare results of segmentation. we use for channel images because we use satellite images instead of aerial imagery. Satellite images used in practice for the practice applications, not for academic usage, and we need to compare results with 6-channel images and 4-channel images using only one near-infrared channel with standard RGB channels. As we shown in our study, the results are very good corresponded.
Thank you for your answer. And then now we must move for the next presentation.
Network methods for searching additional functions set for groups of information-driven permutation operations as a means of increasing the sustainability of critical infrastructure. Introduction. The problem of finding the methods to search new function sets, for example, the additional function sets for groups of information-driven permutation operations, for general and special purpose intelligent computer system is relevant today. The additional sets of function for groups of information-driven permutation operations can be used secure communications with critical infrastructure, increasing its defense against hacker attacks. The definition of the new sets of information-driven permutation operations is relevant since these operations have a very large number of modifications. Exact methods for new function sets finding have a computational complexity. Methods for finding additional function sets for groups of information-driven permutation operations based on local search and have a high probability of hitting a local extremum. Random search solution methods don't guarantee convergence. So the problem of insufficient efficiency of existing methods is the background for the research. Methods based on associative neural networks and methods based on translation neural networks are the important among the methods used to establish associative relationships between objects. Methods based on associative neural networks was divided into methods with associative, heteroassociative, associative, and heteroassociative memory. Object, subject, purpose, and objectives of the research. The object of the research is to find additional function sets for groups of information-driven permutation operations. The object of the research is methods for determining the search for additional functions set for groups of permutation operations information-driven based on neural networks with associative memory. Purpose of the research is to improve the searching efficiency for additional function set for groups of information-driven permutation operations using neural networks for associative memory. Objectives of the research: to create a method for neural associative search of additional function sets for groups of information-driven permutation operations, to conduct numerical research of the proposed optimization methods. Research problem. The problem of improving the searching efficiency for additional function set for groups of information-driven permutation operations comes down to the issue of finding such a vector of parameters that satisfies the adequacy criterion of the functional module in artificial neural network based on associative memory. It is presented in the form of deliver the minimum mean square error, the difference between the model and desired output. The method for neural associative search of additional function sets for groups of information-driven permutation operations. The variables of permutation. 3-bit elementary functions were selected as input variables, which are the sum of 3 elementary functions. The data model of this function is similar in complexity to the sum Model 2, there are basic groups of information-driven permutation operations and function numbers in decimal format. The values of the main element of 3-bit elementary cryptographic transformation function were a basic set of groups with a number its combination were selected as input variables characterizing the key for searching new data sets. The output will result in 14 bits. Specification requirements. The minimum number of functions is 1. The minimum number of basic groups of information-driven permutation operation is 764. The function number in decimal format must be indicated. The key for searching new data sets must be specified. Specifications are filled out in one language. The maximum allowed number of input variables is 16. The structure schema of the bidirectional recurrent correlation associative memory neural network model. The structural schema of the bidirectional recurrent correlation associative memory shown in Fig 1. It is a recurrent N with one hidden layer. The bidirectional recurrent correlation associative memory. It implements heteroassociative memory. Its element is represented by a pair of samples, and autoassociative memory. Its element is represented by a pair of samples and restores the stored samples pair using a k sample corresponding to the first vector or a k sample corresponding to the second vector. The main program options are correlation matrix associative memory with a linear weighting function, which is similar to the hopeful neural network, the memory capacity number of pairs. High order correlation associative memory with power law weighting function, memory capacity number of pairs is. Exponential correlation associative memory with exponential weighting function, memory capacity number of pairs in case and. The most important property is that the same n with the same connection weights can store and reduce several membered samples. Barcam has the following benefit. It is used to transcription pairs of samples. It provides good generalization quality. The submitted sample may be noisy or have missing information. It doesn't require determine the number of hidden layers, one hidden layer. It doesn't require determine the number of neurons in the hidden layer with the number of trained samples. Parameter identification occurs in one iteration, so parameter and structure adaptation occur quickly. One-step training is used to train Barcam. The identification of Barcam and model parameters training phase. The training set is specified. The ways of forward and feedback connection are initialized. Then Barcam function model recovery phase return of sample and sample by vector. Experiments. Numerical research of the methods was carried out in the Google Colab software environment. The dataset is located on GitHub with the length of the binary sample, the number of input neurons, the length of the binary sample, the number of output neurons, the number of training pairs, the training set power for the BEM or the number of neurons in the hidden layer or Barcam. The comparison results of the bidirectional recurrent correlation associative memory with bidirectional associative memory based on the criterion of mean square error, associative memory capacity, and computational complexity, functioning through basic groups of information-driven permutation operations is presented table 1. The comparison results as overcome with B. Mean square error, capacity, computation complexity, function. Discussion of results. Advantages of the proposed methods. The bidirectional recurrent correlation associative memory, which used getter-associative and outer-associative memory and an exponential weighting function, allows to increase the capacity of associative memory while maintaining learning accuracy. Type 1. Bidirectional associative memory, which uses getter-associative and outer-associative memory, allows to increase the speed of functioning while maintaining learning accuracy. Type 1. The methods make it possible to expand the scope of neural networks with associative memory application, which is confirmed by the adaptation to problems of searching for additional function sets for groups and information-driven permutation operations, and helps to increase the efficiency of intelligent computer system for general and special purposes. Proposed methods of finding the additional sets of functions for groups of information-driven permutation operations can be used to increase the sustainability of critical infrastructure facilities by improving their security and means of external control and communication. Conclusions. The existing statistical and machine learning methods were investigated to solve the problem of insufficient efficiency in finding additional features that for groups of information-driven permutation operations. Research results have shown that neural network methods are the most effective today. A recurrent correlation associative memories modification made it possible to use this neural network for getter-associative memory. The exponential weighting function allows increasing the capacity of associative memory, which stores 3-bit elementary functions for cryptographic transformation, basic groups of information-driven permutation operations, elementary function numbers in decimal format, and a search key new data set, and the results in the form of a new set of keys. Perspectives for further research include studying the proposed methods for a wide class of artificial intelligence problems.
Good. Thank you for your presentation. Dear colleagues, do you have any question? If nobody have question, I have some question. Can you explain how bidirectional recurrent correlation associative memory differs from traditional bidirectional associative memory in terms of capacity and computational complexity?
Big capacity. Bigger capacity.
Okay, thank you. Any other question? And one more question for me. What are the primary advantages of using neural networks with associative memory for searching additional function sets for information-driven permutation operation compared to other methods?
Two advantages. First, the bigger capacity. Comparison ordinary PEM. Two advantages. Bidirect. And used for X to Y, and Y to X reconstruction. For example, for encryption or decryption.
Thank you for your answer, and we must move for the next presentation. I hear the presenter here, and let's start.
Thank you.
My name is Taras Puchko, and I am a PhD student in the Georgy Pukhov Institute for Energy Modeling of the National Academy of Sciences of Ukraine. I am currently working under the supervision of Professor Sau Serhiy Ivanovich. Thank you for an opportunity to present a method of forecasting software development effort required for sustainable web API evolution. Web application programming interfaces are rules and protocols that allow distributed parts of software systems to communicate with each other. In the field of energetics, web APIs play a crucial role in facilitating data exchange, communication, and integration among various energy-related applications, services, and platforms. As a mechanism for handling real-time, online, and historical energy data, web APIs can support interoperability in smart cities, facilitate decision-making for energy sustainability, enhance energy presumptions operations, and improve efficiency in smart grids. After initial development, web APIs must continue to evolve to prevent themselves from becoming obsolete. Project managers need to know how often web APIs will change and what development effort will be required to perform such changes in order to plan months ahead and effectively allocate resources. In order to forecast software development effort for a particular time interval, one needs to predict the distribution of change requests and then estimate the effort for each change. The first part can be solved with a time series forecasting model. The existing literature shows successful forecasting based on both traditional methods and deep learning models, given change data exists for 7 to 20 years. However, the changes were not differentiated, so considering different types of them could improve the forecasting. An effort has to be estimated for each change predicted by the time series forecasting model. The methods to achieve that can be based on expert knowledge, size, model, analogy, regression, optimization techniques, fuzzy logic, machine learning, and artificial neural networks. We couldn't find any study of applying such methods to web APIs specifically, but taking that into account can improve the estimates. To forecast software development efforts needed to support web API evolution, we propose building a representative model that captures the historical patterns and trends. To demonstrate the proposed method, we have collected the API changes for 3 years from the Stripe API changelog and classified them. For each change type, we have built a representative model separately in the following way. The 3-year time series containing the change count was split into multiple 7-day time series. For each weekly time series, the mean and standard deviation of the change count were calculated and used to group the weeks into several clusters. For each cluster, a representative week was found. A forecast of change count was built by adding representative weeks proportionally to the cluster size. Based on that forecast and estimated effort of one change, a forecast of effort for a specific change type was built. The last step was combining forecasts for different change types into a single forecast. As a result, we have obtained a representative graph that does not predict exactly the effort required to support Web API evolution for each day, but it captures the patterns and trends, allowing project managers to make better decisions on project budgeting, analysis of risks and trade-offs, planning and controlling the project, and analysis of investments into software improvements. The proper management decisions effectively make Web API evolution sustainable when APIs are always able to meet changing requirements. Concluding, we can say that keeping Web APIs up to the task is crucial for the energy industry to meet the requirements of energy data access, renewable energy integration, grid management, smart home and building automation, energy market information, electric vehicle integration, energy efficiency and monitoring. To maintain Web APIs efficiently, we need a way to predict the future software development efforts. A representative model of future efforts can be built using cluster analysis of historical data. Such a model can be used in the planning process by organizations involved in building and supporting Web APIs. Future directions of research or improving forecast precision may include using machine learning techniques such as random forest ensemble learning method and multi-layer perceptron artificial neural networks. Thank you for your attention and time, and now I am happy to answer any questions you may have.
Thank you, Taras, for your presentation. And dear colleagues, do you have any question? If nobody have a question, I have a few. What can you tell about the limitation of your research? All kind of software may be the subject of your research.
Well, as you see, the changes of Web APIs are highly irregular. So on one day we may have tens of them, on the other day we may have nothing. So we cannot really predict any change for tomorrow or for even for the next week. So this model, it does not exactly predict the changes. It only allows to see the patterns, to see what is most likely we will see in the future. But it does not isolate us from unusual changes or from unforeseeable changes. That is the most drawback of that method.
Okay, and at your presentation, you talk some about the future direction of your research, but can you tell more about it?
Well, as you see, I have used more traditional approaches, but in the future, I am going to use kind of artificial intelligence methods like neural networks and deep learning models that can handle bad underlying patterns and detect such, find some patterns that we cannot even see, even person cannot see them, but a deep learning model can detect it. And this way we could predict future better.
Okay, and dear colleagues, any other question? No question, but we have 4 minutes. So your topic is very interesting, and the future direction to use AI methods is so very interesting. But if there are some data for the training AI model.
Yeah, that's an important and hard question, because from what I see in literature, the existing studies are usually based on very long periods of data, historical data, like 20 years or 7 years. And most software projects do not live that long. And that is a place where it will be hard to find enough information to train models. So, for example, in my research, I have collected only 3 years of data because it was the only data I had. Well, maybe for specific projects, you see there are some long-living software projects like Eclipse development environment, or some software projects that lives for a long time. We can take that data, but usually we are not so interested in those projects that live for a long time. We are mostly interested in projects that are current. So we are interested in how new projects will evolve, not for the, and that is a place where it will be hard to find enough information. I agree.
Thank you for your answer. Dear colleagues, any other question? Any comments? If nobody have question and comments, we will go to the next presentation. Just a minute.
Dear colleagues, with this presentation, we would like to highlight the main findings of a research conducted on the key competences of tomorrow for post-war recovery and sustainable development of Ukraine's economy. The study has been carried out at Cherkasy State Technological University by Oksana Zakharova and Lyudmila Usek. Today, the speaker is Lyudmila Usek. The research aimed to review the key skills of the future based on a comprehensive assessment of those competencies that in practice are able to achieve each sustainable development goal and accelerate the pace of technical, technological, and innovative growth to approach Industry 4.0. The study addressed 3 major issues, all adding up to the overall goal. First, we specified those personal skills that will enable the country to achieve the Sustainable Development Goals. Next, we analyzed 5 groups of personal skills that are considered to be the key skills of the future in terms of their ability to facilitate the Sustainable Development Goals and approach Industry 4.0. And finally, based on the above, we addressed individual standards of higher education provided by the Ministry of Education and Science of Ukraine for bachelor degree level in terms of the question if they offer the key skills of the future to the students. The study relied on a vast array of statistical data, which is representative in terms of the chosen topic. The sources are presented in this slide. At the preliminary stage of the study, we have constructed a cloud of keywords selected from the literature to visually represent the research vectors prevailing in our topic today. Focusing on these vectors, we will be able to outline the list of key skills which will allow Ukrainians to shortcut their route to complete restoration of Ukraine's economy in the post-war period. We only have enough time to name the most important of them, while their definitions and detailed descriptions will be found in the full text of our article, which we invite you to read later. Having defined the key aspects of the future skills, we attempted to establish the connection between the skills acquired by individuals while pursuing a university degree and each of the Sustainable Development Goals adopted by the United Nations in 2015. Thus, Sustainable Development Goal number 1, no poverty, can be achieved by a society in which the majority of the workforce have mastered skills such as motivation to master a profession, finding a rewarding job, and entrepreneurial skills. Goal number 2, that is zero hunger, can be supported by productive work and the ability to master innovative technologies. The society in which the majority of population possesses skills such as the cult of a healthy lifestyle, supporting personal health, stress resistance, and psychological flexibility, will have higher rates of good health and well-being, which is goal number 3. Skills such as scientific activity, innovative work, active lifelong learning, analytical thinking will assist the society in achieving goal number 4. The same applies to the goals number 5, gender equality, goal number 6, clean water and sanitation, goal 7, affordable and clean energy, and goal 8, decent work and economic growth. All these goals will also be ensured by corresponding skills presented in this slide. Achieving goal 9, industry, innovation, and infrastructure, will also require specific skills of the future from the population. The same applies to Goal 10, which, as we all remember, is titled Reduced Inequality, Goal 11, Sustainable Cities and Communities, Goal 12, Responsible Consumption and Production, Goal 13, Climate Action, Goal 14, Life Below Water, Goal 15, Life on Land, Goal 16, Peace and Justice and Strong Institutions, and Goal 17, Partnerships to Achieve the Goals. The presentation will be available after the conference, and if you would like to have a closer look at the corresponding skills sometime later, you are welcome to do so. Now, I would like to proceed to the next stage of our research. Having defined the skills of tomorrow based on their alignment with the declared Sustainable Development Goals and Industry 4.0 requirements, we divided them into 5 groups according to the nature of the skill. The first group includes personal and communication skills, such as communication, ability to work in a team, leadership, psychological stability, and other related skills. Group 2 includes knowledge and organization skills. Group 3 covers skills related to intellectual and innovative work. Group number 4 encompasses skills related to resource conservation and resource efficiency. And finally, group number 5 includes tolerance and quality of life skills. Again, I invite you to see more detail in our presentation after the conference. In order to assess If higher educational institutions in Ukraine are focused on providing students with the key future skills, we have analyzed the contents of the current higher educational standards for bachelor's degree programs in terms of graduates' competencies. Table 1, which covers this and the next slide, summarizes the coverage provided by the current higher educational standards for the 5 groups of the key future skills that we have discussed in the previous section. The pluses in the table indicate the frequency of representation of the group of the skills in the educational standard. Again, I would like to remind that here we are analyzing the current higher educational standards for bachelor degree programs, and this slide is the continuation of the table that visualizes the frequency of skill representation by group for 12 or more specialties. All the specialties could not fit into one slide, and the results of this study, if you take a look at this table, indicate that current bachelor's degree programs in Ukraine offer at best a superficial coverage of the key future skills. The following conclusions can be drawn from the present study. Investigation of the first group of skills, that is personal and communication skills, revealed that only 5 out of 25 specialties this educational standard requires provision of the skills related to this group. Knowledge and organization skills are prescribed for only 4 specialties, and standards for only 8 specialties include teaching intellectual and innovative skills into the requirements to educational programs. Resource conservation and resource efficiency skills are least presented in the educational standards. Surprisingly, tolerance and quality of life skills were found to be most extensively represented in the educational standards. To sum up, I would like to remark that in recent years, Ukrainian educational system has been gradually moving towards compliance with international standards of basic documents for education management. This period is expected to be most favorable to introduce the key skills of the future into the educational programs. Providing students of all specialties with skills of the future will promote implementation of sustainable development goals, smart specialization, smart economy, and digital economy. In addition, inoculation of these skills will reduce the time the Ukrainian young people would otherwise need to adapt to the new living conditions, which, due to the rapid development of artificial intelligence and the latest technologies, will soon alter the global professional landscape. Dear colleagues, thank you for your attention, and we would like to invite you once again to get acquainted with the full text of our research, which, as we hope, will be soon available.
Thank you for your presentation. Dear colleagues, do you have any question?
I have one.
Yeah, please.
Talking about the Industry 4 and the restoration of the Ukrainian economy after the war, and talking about the skills and the categories of the development and so on. I think, that it's linked not only with Ukraine, but with any country in the world. But when we're talking about Ukraine now and the future of Ukraine, I think that first of all we must talking about the safety, about defense, about the specific medicine for thousand soldiers coming back with loss of health. And this is specific questions. And this question does not reflect in your report. It's very strong for me, very strange for me. Thank you.
I just thank you for your remark. And here we both totally agree with you that Ukraine has specific issues and specific problems that should be addressed. And these problems are not yet reflected in the educational standards. Of course, this is a problem we should work upon, the whole Ukraine should work upon. Together, universities, like higher education system, school education system, the authorities, the management, the highest levels of the country's management. This is something we have to turn our attention to. But these problems, these issues, and the skills that would address these issues directly are absent in the educational standards today. However, those skills that are present there can partially and indirectly somehow, help us approach that industry 4.0, and indirectly this will create the basis for successful solving of the issues you have mentioned, although I agree not directly. Also, the format of this conference requires addressing more general issues. So this is why this topic was chosen. I hope this answers your question.
Thank you.
Mihailo, please.
Oh, okay. Question about how do you see the role and place of soft skills in the curricula for bachelors? I mean, creativity, critical thinking, literal thinking, emotional intelligence, and so on.
Yes, thank you for your question. The skills of tomorrow, the future skills that we have analyzed, they belong to the group of transferable and soft skills. Only according, the difference is according to the World Economic Forum that was in 2015 that defined these skills. So the ones that we have analyzed are going to be the most important ones and the most required ones up to the year 2025. And of course, the hard skills are the most important part of any curriculum. The students come to the university to master a specialty, a profession. But today's world functions in such a way that the skills cannot be isolated from each other. Hard skills, soft skills, and the group of future skills that belong to the soft and transferable skills as well. So they should be inoculated, they should be offered to the students like a complex system, like a whole. And also, I had a thought, but I lost it somehow while answering. Well, maybe I will remember that later.
Thank you.
Thank you, colleagues. Any other question? I have a little question. In the table, in which you present the case skills of tomorrow, I didn't see the skills of resilience. And watching on the topic of our workshop, I must ask you, what do you think about the concept of resilience as the case skills of tomorrow?
Yes, resilience as a skill actually belongs to the group to one of the 5 groups that we have analyzed in the article. Of course, in the presentation, we simply did not have time enough to cover and mention each skill, but it was in one of the groups. So it is somewhere in one of the groups that we have analyzed.
Thank you so much. We must move to the next presentation.
Hello, my name is Mike Prazyan. I'm a researcher at Mykolos Romeris University, and the presentation is about sustainability and resilience, digital technologies for G&G Scope 3. The present sustainability, resilience, and climate agenda constituted by the Paris Agreement and the United Nations Sustainable Development Goals stands behind the approved milestones for 2030 and 2050s. Many reasons indicates a little progress. And a sufficient level of digital scientific program, education, literacy, refer to decarbonization and digital technologies. The presentation aim is describing benchmark and digital platforms to ensure data monitoring, management, and carbon reduction. The study considers Scope 3 issue via the lens of the supply chain with idea to unzip the potential for environment protection and better sustainability and resilience. As you know, G&G's greenhouse gas protocol defines 3 scopes. Scope 1 is about primary emission that belong to the companies. Scope 2 is indirect emission, and Scope 3 is emissions that don't belong to the company, and exactly Scope 3 is linked closely with supply chain. You can see it at the picture. Why Scope 3 is the point of high significance? The reason is that Scope 3 constitute about 70–80% of total emission, number one point. The second point is Scope 3 is 5.5 times larger than Scope 1 and Scope 2 emission altogether, and more than 11 times, more precisely 11.4 times larger than Scope 1. Why specific point is that problem stakeholders and carbon emitter encounter is so-called long tail dependency on suppliers, because stakeholder sometimes doesn't have control and have dependency on suppliers. To provide a strategy of carbon reduction, stakeholders need to manage Scope 3. For this purpose, they need to monitor and measure current level, manage it, and reduce. As you could look at the picture. At this picture, you see the regulatory environment with regard to Scope 3 and ecological, social, and governance policy, ECG. Since 2024, this year, reporting becomes mandatory in the UE and affiliated countries. You could see as a picture. To provide a comprehensive measure, there is needs to obtain to be familiar with plenty of technologies, and the role of these technologies shown at this slide. Coming back to the digital technologies, scientists, the researcher indicates 11 most significant technologies, namely artificial intelligence, 3D printing, blockchains, proximity technology, robotic digital application, computing, gas portal technologies, immersive environment, IoT, open and cross-based platforms. Subject of technologies has a serious connection with technology readiness level invented by NASA and there is huge influence with regard to the level the technology stand. The first level is weak level of development, technology development, and the highest is 9. Because of the fact that most corporations and SME doesn't have relevant online system for monitoring and management of G&G data gathering for it leaves a lot of requests to support from the getting access to the benchmark and cooperation with consultancy. One of the best sources of benchmark is the Science-Based Target Index. And if company have capacity to address to the digital platforms and key provider, digital provider, they could help, but not always for free. More specifically, it is Sustainalytics, MCSI, Persephone, Gwendoline 2, Impact, Clarity IE, Climate Intelligence Platform, MarketSite, Workiva, EcoVadis, the Hero platform, and some others, as you see it at the slide. The next slide delivered case study with regard to the information and communication systems, ITC system, as a part of general class of the critical infrastructure. You know that critical infrastructure comprised of energy sector, transport sector, agri sector, buildings, and many others, including digital infrastructure. The information and communication systems are the key element. You could see a structure of ICT systems that encompass the infrastructure and ICT services. And this current status quo is not simple, because now ICT sector issued about 2% of the total global emission, with tendency to spike in upcoming decades. What is interesting today, ICT sectors consume 4% of total energy production, with tendency to rise until 14%. This slide demonstrates specific regulation and standards with regard to G&G Scope 3 management. For sure, providing new technology and even addressing to the benchmark of digital platforms require sustainable access to the sustainable finance, and vice versa. Companies could get sustainable finance if they will meet to the ESG regulation and status and ratings. The same situation with education, because new technologies require new skills, providing upskilling, reskilling programs, and so on. And to conclude, Today is stakeholders need to address to human-computer interactions because of computing and digital technology doesn't have relevant level of development. Stakeholders need to address to the benchmark and digital platforms and provide tech expansion and digital resiliency and sustainability in order to manage scope 3 in particular, must be ready at whatever happens for time of peace or for times of war. Thank you for attention. Here is my contacts.
Thank you for your presentation, dear colleagues. And, do you have any question?
I have one.
Yeah, please.
When we're talking about the new technologies in order to decrease the emission, what do you think? It is well known, and you know that some technologies solve this problem not radically. But for example, we know some technologies that transfer the problem of emission in time. So they produce some product that keeping during a long time, and it means that this product must be reproducing or using or need in other technologies that not opened now and unknown now. But the technologies transfer the problem in time. And the transfer the problem in time must be included as the parameters, the factors that it needs to estimate and to planning the development with take into account these factors as the main factors between business, stakeholders, very quickly find the easy way to find decision in production and new technology with solve the problem for a short time, a short period of time. But they does not need to think about the future that coming over the 10 years or 20 years. What do you think about this?
I think that that is absolutely fair statement, and that is why the article and presentation keeps focus specifically on the scope 3, because a long tail of problem that came from the waste management, for the recycling, for instance, for nuclear power stations, for renewable energy. The situation is not easy with even solar panels, as we know, yes, or many other points. Yes, accumulators, the same, raw materials problem, lithium. That is specifically related to the scope 3. Scope 3, and for now, the regulators in the world, in Ukraine as well, and key player doesn't pay additional attention to this problem. People play blind eyes as if the problem doesn't exist. Yes, that's why the key evil, sometimes remedy is worse than it seems. Yes, Number 1 point. The second point, possible solutions could be found probably on the more natural way of energy efficiency and establishing circular supply chain, circular economy. Current status is too far to be desired now, and we need to allocate a lot of scientific and practical efforts to resolve this problem. I'm absolutely with you in this understanding.
Thank you. Thank you.
Dear colleagues, I remind you that we have opportunity to continue discussion in chat, but now we must move to the next presentation.
Dear colleagues, I would like to present a report reducing the risk of power equipment failure when using information from information measurement system of vibration diagnostic rotation units or auxiliary engine of power plant. The power station are in critical infrastructure, so reliability and resilience of its operation is an important component of state security. The reliability of the power equipment is closely related to the effective monitoring and diagnosis systems they are equipped with. The construction of such systems takes place in several stages: the elaboration of mathematical models of information signals of such systems, the selection of the most informative diagnostic features based on the analysis of such models, the construction of training tests and decision rules. When solving such a problem, the theory of probability, theory of random process, theory of risk, machine learning theory of statistical hypothesis, the theory of pattern recognition are applied. Any complex technical facilities can always be viewed as a hierarchical structure. Thermal power plants contain a large number of units, mechanisms, machines, and structural elements. The individual units and components of thermal power plant collectively constitute certain functional blocks, the reliability of which to a certain extent depends on the reliability of the equipment included in each block. Science defects in the component part are actually defects in the facility as a whole. The auxiliary equipment of power plant includes mechanism for servicing of automation, the operation of the main units and auxiliary devices of the plant, intra-station power grid and switchgear, as well as heating, lighting, and so on. Prototype of a wireless diagnostic system was developed in the Institute of Electrodynamics, Ukrainian National Academy of Science. The analog signal measured at the units of the electrical machines under diagnosis at the output of the sensor is duty cycle modulated signals. The ADXL202 accelerometer manufactured by analog devices was used as primary sensor. The sensor unit used in the developed prototype of the vibration diagnostic system consists of the following basic elements: 2 ADX accelerometers, microcontroller manufactured by Microchip Technology, Bluetooth module manufactured by Toyota, related elements, and ensure the full functioning of the unit. Using the creation prototype of the information system, research of the vibration characteristic of auxiliary engine of Darnitskaya head of power plant was carried out. The developed vibration model of the prototype of diagnostic system was used to measure and analysis of vibration information signals recorded on the bearing unit of rotation shaft of the DICA RIE 4519 for V electron model. The development of diagnostic systems that cover all possible elements of power plants is too complex a technical problem. Therefore, when a diagnostic system is developed, it's necessary to determine which elements of the object to be diagnosed are critical for its proper functioning and which are less critical. It is advisable to divide all possible defects in a given object to be diagnosed into three classes: catastrophic defects, non-catastrophic defects, and partial defects from the point of optimization, the complexity of the diagnostic system. Method of resilience estimation of actual electric drivers of power plant was applied. We used the methodology proposed into the access the impact of auxiliary motors of the power plant's resilience. According to the definition of the United States National Academy of Sciences, the structure as a model of the object of study is modeled as a graph G of NE, when N is the number of nodes connected by links L. The specification N and L includes characteristics related to the resilience, such as capacity, location, and the impact of each node, and connection lines of the functioning of the object research. We tried to develop the schematic diagram of the main auxiliary motors involved in the operation of power units at the blocks of Tripolian thermal power plant. A critical functionality by which resilience is estimated with following equation, where NL is the set of the all needs and links of the graph, where sub E of TS is a measure of the relative importance of node or link I at the given time t. P sub E of TS is the degree of which the node is still active in the presence of all attack. E is a class of adversible events or potential attacks on target nodes. Resilience. Resilience is a complex function of the topological property of the network and zero-time evolution parameters defined for a certain critical functionality and class of adverse events E. The definition of resilience are shown at the slide 11. The paradigm of risk analysis in the energy sector is certainly related to the risk paradigm that exists in the development of cybersecurity systems. According to this paradigm, risk information security includes three main dimensions: confidentiality, availability, and integrity. The additive risk model of information security can be presented as follows, where R sub C, E sub C, confidential risk, R sub E, P sub E, integrity risk, and this one, availability risk. Risk identification. The following paradigms are possible to access the risk of power unit failure. R sub P, P sub R sub C, P sub C is a confidentiality risk. Is correspondent to the risk of unauthorized access to the wireless receiver and the technical condition of such receiver. R sub C, P sub C, integrity. It is estimated service life and probability of failure of a power equipment. R sub E, P sub E is availability risk. It is the actual service life and probability of failure of a power plant, which depends on the operation mode and technical indicator. For example, for vibration, it's according the following international standards could be applied for estimation of this operation modes and temperature indicator load characteristic could be estimated with application of the international standard. Conclusion. The relevance of the result obtained is due to the fact that in the post-war period, one of the main problems of the country's reconstruction should be the restoration of its united energy system, including generation equipment. It's necessary to restore generation at a fundamentally new level with the use of advanced achievements of the world and domestic electrical engineering. Such restoration involves restoration not only the main generation equipment, but also auxiliary equipment, which may not be severely damaged during enemy attack. But it's necessary to assess the risk of its failure and impact of the functionality of all part equipment. This assessment can be made using the concept of resilience. Thank you very much for your attention.
Thank you for your presentation. Dear colleagues, do you have any question? If nobody have question, I have a little 1 second. Can you explain how the implementation of an information measurement system for vibration diagnostic enhance the reliability and operational efficiency of auxiliary engines in power plants more highlight?
Okay, I'm sorry, but we prepared this presentation before, for example, Tripoli APP station was destroyed. But now we have some problems with this. And for implementation of the method, we consider only vibration characteristic. But when we consider attack for some power station, we have to use results of this attack. For example, Tripoli state power station. Tripoli power station, we have fire in the turbine room. Okay, what we have to do? We have to change, for example, basic equipment. But what about auxiliary equipment? We have to estimate of their technical state. Vibration diagnosis would be applied for the analysis, but it is not only this, because we have to estimate a state of motor isolation code when we use fire on the equipment. And the so-called law of 6-degree temperature could be used for the estimation. But resilience method, it's very important. It's very important for analyzing our possibility to reconstruction station. Okay, Tripoli station. One way, we have to exchange all equipment, for example, by combined cycle plant. But when we have a gas, okay, we try to implement modern coal technology. In this situation, we can use auxiliary equipment, and we have to estimate technical state of this equipment. I'm sorry, please understand you.
Yes, thank you so much. And I don't saw any other question. And we move to the next presentation.
Greetings, ladies and gentlemen. My name is Rizky Insan Imanwaji from Universitas 11 Maret, Indonesia. In this 5th International Conference on Sustainable Futures, Environmental, Technological, Social, and Economic Matters, I will present my study about collapse behavior of double-layer pipes review. There are 6 main content for this presentation. The first one is introduction, and then double-layer pipe application. Continuing on, there is double-layer pipe configuration, and the fourth one is applied load on the double-layer pipe. Proceeding further, there is collapse behavior of double-layer pipes, and the last one is conclusion. Coming to the first section is about introduction. Pipes serve as essential conduit for fluid transportation across diverse industrial sectors, especially in marine industry. Pipes also come with single-layer configuration or double-layer configuration with many different materials. A double-layer pipe, or DLP structure, refers to a pipe within a pipe, or encased in an outer covering with an annulus between the two diameters. A double-layer pipe also can be considered a modern pipe structure. In this article, we will focus on studying collapse behavior of double-layer pipe under bending load and external pressure by comparative study of various pipe failure articles and various double-layer pipe configurations that have been studied. Moving to the second section is about double-layer pipe application. DLP usually used in marine industry sector because of its unique characteristic. For the DLP application itself, usually used in deep water oil and gas pipe, also cold water pipe or CWP, in ocean thermal energy conversion or OTEC. For the deep water application, DLP will provide exceptional resistance against corrosion, cathodic disbondment, as well as abrasion and physical damage. And for CWP application, composite material are usually preferred for this construction because their high strength and lightweight property, especially in double-layer pipe configuration. Continuing on to the third section is about double-layer pipe configuration. A DLP, or double-layer pipe, is a secondary containing piping system that consists of an inner and outer pipe with an interstitial space between the inner and outer layer. Basically, a DLP is a pipe that has core between two pipes, inner and outer pipe, which is usually have a different material or configuration for the pipe and the core. As for the core configuration, there are first stiffener core. Stiffener core is a core that is made by using different stiffener configuration to make some kind of pattern. Usually, it is used to increase the strength of the pipe, but still achieve the lightweight structure. For the example, stiffener core are isogrid core, that is a grid stiffened structure where the grid make an equilateral triangle that is built from a combination of helical and circumferential stiffener. Isogrid core also can be seen in the first figure. Also, there is IZO and V core. IZO and V core is basically a core that has different stiffener structure. And each one of them will resemble that its name. Other type of the core configuration is solid core. Solid core is a core that is made by a solid material. The material itself can be vary. For the example are cement annulus core. Nah, cement annulus can be considered a solid core and can be consist of strain hardening cementitious composite or SHCC or fiber reinforced cementitious composite or FRCC, and many other cement composite. Another example is polypropylene core. Usually, it's made for lightweightness. That is a core made by polypropylene material. Proceeding further to the fourth section is about applied load on double-layer pipe. For the first load that usually double-layer pipe receive is a bending load. Bending load represent one of the major load experienced by underwater double-layer pipes. These loads arise the surrounding water weights, ocean underwater current, and the pipe on weights. For the bending moment, formula of the pipe can be calculated using this formula. Sigma bending equal to M times D divided by 2I, 2 times I, where sigma bending is a bending stress, M is a bending moment, D is outer pipe diameter, E is pipe moment inertia. For the second load that DLP usually receives is hydrostatic pressure load. Hydrostatic pressure load is exerted by a fluid at a rest at a given point within the fluid. Due to the force of gravity, it is proportional to the depth measured from the surface. It is the main load that underwater DLP need to withstand. As illustrated, when hydrostatic pressure is exerted, pipe may collapse if the disparity between external and internal pipe pressure becomes too high. For the calculation formula, you can see at my journal, at my paper. Coming to the fifth section is about the collapse behavior of double layer pipe under bending load. Under bending load, the first factor that affects the buckling moment is the pipe length. The buckling mode shape of the relatively short DLP has short wavelength ripples like in figure A. Meanwhile, the relatively long double layer pipe does not show any wrinkles along the pipe like the figure C. As can be seen, the number of wavelength is changed linearly with the respect of the pipe. This indicates that the buckling moment of longer pipe is smaller than shorter pipe as shown in this graph figure. The second and third factor that affect the buckling moment are the core thickness ratio and the core stiffness ratio. For the core thickness ratio, the DLP with thicker core layer shows deformation magnitude of external layer is considerably larger than the internal layer. But thinner core thickness show that the deformation profile of internal layer is like external layer in smaller magnitude. Increasing the external layer diameter also increase the buckling moment of the system, can be seen in the figure in the graph A. And the core stiffness ratio also significantly affect the buckling moment of DLP, as well as the buckling mode shapes. In this case, buckling moment will increase exponentially with the increase of the core stiffness, as shown in graph B. Furthermore, in the fifth section, there are collapse behavior of DLP under pressure load. As in figure, the buckling modes of DLP under external pressure is different than the buckling load of DLP under the bending load. The buckling modes of DLP under external pressure form an axial half wave and four circumferential wave like in the picture. Continuing on, the critical buckling pressure is affected by radius to thickness and core ratio of core thickness to inner and outer thickness. Generally, the critical buckling pressure diminish as the radius to thickness ratio increase, as demonstrated in the figure A. And for the ratio of the core to inner and outer thickness influence the buckling pressure of DLP. An increase in this ratio lead to rise in critical buckling pressure, as indicated in the graph B. Finally, for the last section, we can conclude five main points from the study. The first one, primary factor affecting the buckling strength under the bending force are pipe length, ratio of the core thickness, and the core stiffness ratio. Pipes with greater length have a similar buckling moment, have a smaller buckling moment, an increase in both core diameter and stiffness, and hence the buckling moment. Primary factor affecting the buckling pressure are ratio of radius to thickness and the proportion of the core thickness relative to the thickness of outer and inner layer. The critical buckling pressure diminish as the radius to thickness ratio increase, whereas an increase in the ratio of core to outer and inner layer thickness boosts the critical buckling pressure. For the last, I would like to extend my gratitude to each and every one of you for invaluable presence and active participation throughout my presentation. If you have any question, please ask, and we will open the discussion. Thank you once again.
Thank you for your presentation. Dear colleagues, do you have any question? I have a little question. How do different core materials and configuration such as ISO grid cores or compiling cores impact the performance and collapse behavior of double layer pipes in underwater application.
Okay, for the different material and configuration in the core of the pipe impacted the collapse of double layer pipes. Usually, material like cement tend to have a higher collapse pressure than polypropylene material. And for the configuration, usually the different in the stiffener configuration, like in O pattern or isogrid pattern, have a tendency to have different critical collapse pressure or maybe bending. So with each different configuration or material, each pipe will have a different strength, also different property.
Thank you, dear colleagues. Any other question? I don't see any question. So I have one more. Could you discuss the practical implementation of your research for the design and operational strategies of double layers pipes used in deep water environments, particularly in the contents of oil and gas transport and ocean thermal energy conversation?
Okay, so if I'm right, the usage of double layer pipes in ocean energy transport or ocean thermal energy, it's right?
Yeah.
Okay. So for the usage, usually double layer structure used in oil and gas transport because it has isolation capability, especially in the cementitious composite or cement core. It will have a good isolation property and also a good strength to withstand the high pressure of underwater material. And for ocean energy transportation, especially in Indonesia, because we have a lot of ocean, composite and in OTEC application, lightweight and high strength double layer pipe, it's usually preferred because it tend to go from 0 meter to around 500 meter in depth. So it need to withstand a lot of bending moment from the ocean current, also a lot of pressure differentiate, and also because it hang from the platform, it needs the lightweight property of composite material.
Thank you so much. And the last question: what are the primary factors that affect the collapse behavior of double layer pipes under hydrostatic pressure?
So the primary factor is usually the thickness of the pipe. The thicker the pipe is, better to withstand the pressure.
Thank you so much. Dear colleagues, any other question? Any comments? Thank you, Arthur, for the presentation.
I have one question in chat. In what directions it planned to develop the present research?
So it in the direction I've planned to develop this research is to make a good double layer pipe for the OTEC application, because right now in Indonesia we are planning to get OTEC technology around 5 to 7 years from now. So my campus researching in OTEC, especially in double layer pipes.
Thank you for your discussion. And now we must move for the next presentation.
Hello everyone, I would like to present our research on modeling and forecasting the production potential of renewable energy sources in the context of sustainable development. My name is Roxoliana and I hold a PhD in world economy, work at the European Economy and Business Department at Kyiv National Economic University. Collaborating with my colleagues, we have endeavored to explore a critical nexus of global concern, especially the interplay between energy security and sustainable development, with a specific focus on Ukraine. The Ukrainian energy sector is experiencing a crisis, and the necessity of sustainable development in Ukraine's region, as well as energy independence, stems from the destruction of infrastructure and the consequences of dependency on resources. We need to review this current trend. And the current trend is, of course, to develop renewable energy sources at the regional level, resulting in more decentralized model. The structure of our presentation includes the relevance of renewable energy, the comprehensive review of renewable energy and forecasting models, materials and methods starting hypothesis, results and discussions, and of course conclusions. The relevance of renewable energy is due to a number of significant factors that affect modern society and the near future. The use of renewable energy helps reduce the negative influence on the environment because at the moment the increase in greenhouse gas emissions and other types of pollution causes severe problems such as global warming, rising sea levels, and other bad consequences. Renewable energy provides an opportunity to diversify and decrease our dependency on finite resources, as we observe today that reliance on traditional energy sources, particularly coal and oil, endangers economies and geopolitical stability, potentially leading to war. To prevent wars and other future conflicts over energy supplies, the potential of renewable energy should be chosen, reducing dependence on imported energy carriers. Renewable energy sources are becoming increasingly significant in the context of geopolitical crisis. The financial market is undergoing a change with a primary focus on increasing corporate sustainability and its impact on business strategies. This can be explained by the Paris Agreement, which places huge corporations in the forefront of the fight against climate change. The important also is the role of institutional investors that in driving companies to publish social information and corporate transparency in the renewable energy sector. The development of green economy should begin at the local level because the dynamic linkages between the non-renewable and renewable energy sources and economic growth are developed very fast. There are like different, of course, different approaches in literature, and of course there are many researchers who already investigated the green economy and especially its importance to implement it in the regional level. Various factors influence renewable energy production, development, and potential, including economic, technological, infrastructural, research, and other considerations. The majority of published studies in the present literature investigates theoretical and empirical correlations. Despite the relationship, there have been very few empirical studies that investigate the relationship between the causality of production and the potential of renewable energy and the factors that determine a country's economic growth, such as export electricity, total final consumption, and total energy supply. So the chosen approach of our research includes system integrity, which is not limited to individual components. Component interaction, especially verification of the cause and effect relationship between the selected variables, and an emphasis on system management to achieve goals, such as optimizing energy production, efficient resource
Pardon,
as well as the development of effective solutions for resource sustainability. We are using the EViews application to model renewable energy production, which is one of the vectors for assuring energy security. And on this slide, you can see the multivariate regression model appears in our research. Renewable energy is a crucial component of ensuring energy security. The use of renewable energy sources allows the country to diversify its energy mix. Instead of relying on scarce resources such as coal or natural gas, which a country may lack or have in limited supply, solar, wind, hydropower, and other renewable sources can be employed. This decreases the risk of energy crisis and helps to provide a more sustainable energy supply chain. In addition, renewable energy is a key strategic method to ensuring the sustainability and securing the country's energy system. And here you can see some benefits of diversifying the energy sources. Globalization has put the world's economies in a new economic context that is linked to the growth of renewable energy sources. However, how specifically and forcefully do the factors influence on the output of renewable energy sources as the vectors of Ukraine's energy security? The answer to this issue can be reached by examining the functional relationship between renewable energy production and the variables being researched. For this purpose, the authors utilize the software product EViews, which enables the generation of results in the form of tables, graphs, and charts. Among the econometric methods available in EViews, we employed descriptive statistic, hypothesis testing, correlation and covariance analysis, regression analysis, forecastings, and pairwise gender causality test to identify the relationship between the production of renewable energy sources and the selected variables. We will use the multivariate regression method. And here you can see the general form of the regression equation in this table. Here we would like to present our results of additional regression analysis, allowing us to examine the impact of chosen variables on renewable energy generation in Ukraine over the 12-year period 2010 to 2021. And we have some results. Especially the expert variable coefficient has a negative impact on renewable energy production, whereas the total final consumption and energy reserves coefficients have a favorable impact. The presence of sufficiently strong connection, no autocorrelation of the residuals, and we have no reason to reject that is, we take it as a basis, and the analysis of the information criteria used in the development of this model revealed that Ekaike and Schwarz indicators are small acceptable values for the model. Here you can see some testing the models of the presence of heteroscedasticity and the quality of the selected variables in the model and its result. And we can say that the multiple regression model predicting development of renewable energy output based on independent factors that was successfully tested. All examinations and testing have confirmed the accuracy of this model for Ukraine, and it means that the equation is statistically significant with a high coefficient of determination. The equation represents an economic mathematical model at a high level of quality, and the model built by the authors is adequate and fully acceptable for forecasting in the future with a deviation of 0.66% from the actual values. So to conclude our research, the authors conducted on renewable energy sources as one of the energy security vectors of Ukraine, especially modeling and projecting their production. We have identified that the presence in a long-term period of factors that affect the total volume of production of renewable energy sources, which is one of the vectors of ensuring energy security, the formation of a balanced and sustainable energy system of Ukraine in conditions of sustainable development. The existence of a strong relationship between the amount of renewable energy production and the total final consumption and the total energy reserve and the correlation coefficients are quite high. The analysis of the coefficients in equation showed an increase in the value of the total consumption variable by 1% should lead to a positive contribution to the production of renewable energy by 0.3%. If the value of total supply increases by 1%, then the value of production will increase by 0.8%. So the modeling and forecasting of renewable energy generation demonstrated a good trend in the context of modern energy security difficulties and a general increase in awareness of environmental pollution problems. This trend, based on Ukraine's experience, demonstrates the active deployment and development of modern renewable energy technologies and increased output of renewable energy sources, including solar, wind, and hydropower, is significant and positive element. So thank you for your attention, and if you have any questions, you can contact us via emails indicated in our article, and we will be happy to continue our discussion.
Our research.
Thank you, colleagues, for the presentation. Is any authors present here?
Yes, I have 2 questions. Tell me, please, what class of models did you use? These models as autoregressive or ARMA models? Because I see from your presentations that we use A criteria and B criteria. It's criteria using for estimation of the model.
Larry, I don't see the presenter.
Presenter.
A few minutes ago, there was Svetlana, but I think they have some trouble with electricity. Can you repeat your question to the chat, and when any author be here, they could to answer to you. I also have some question to the presenter, but have some trouble with present.
Yeah.
So no, it's our life.
It's complex now.
Yes. So I have 4 questions for the authors. I just will write it to the chat, and we will try to continue discussion there. But now we must move to the next presentation, and I just start it.
Is on the assessment of risks for Ukraine infrastructure in the conditions of war. Relevance of research is related to the fact that Russian military aggression against Ukraine, in addition to the large-scale destruction of residential and critical infrastructure facilities and disruption of the regular operation of a vast number of enterprises, led to an unprecedented deterioration in the quality of vital resources and a catastrophic ecological imbalance in the country's natural environment. The catastrophic nature of destruction of the main components of the environment due to the actions of Russian troops, the restoration of which is associated with huge costs of material financial resources, also determines the need to revise the existing methodology in Ukraine for assessing the damage to the infrastructure caused by the Russian military aggression. The purpose of the research is to analyze the regional characteristics of losses of infrastructure objects from Russian military aggression against Ukraine, to assess the risk of damage to infrastructure from artillery and missile attacks at the level of administrative regions of Ukraine. The research tasks are to assess the risks of damage to infrastructure from artillery and missile attacks at the level of administrative regions of Ukraine, to adapt data and use them to evaluate the risk of infrastructure objects according to the model used in EU countries, and to build an appropriate risk matrix of infrastructure losses from artillery and missile attacks and assess its level. The choice of research methodology is primarily due to the need to overcome the uncertainty that arises during decision making on protecting critical infrastructure objects in war. It is also related to Ukraine's foreign policy towards European integration and the need to introduce and adapt modern EU risk assessment approaches to domestic conditions. The research considers a critical infrastructure as an asset, object, equipment, network, or system, or a part of an asset, object, equipment, or system necessary to provide essential services. Essential service means a service that is critical to the maintenance of vital societal functions, economic activity, public health and safety, or the environment. Risk is a possibility of loss or disruption caused by an incident, which can be expressed as a combination of the magnitude of such loss or disruption and the likelihood of the occurrence. An incident is considered an event that can potentially disrupt or significantly disrupt the provision of critical services. In the conditions of war, missile and artillery attacks by Russian troops, which cause the most significant losses to infrastructure objects, are considered incident. The risk can be quantified as a function of the likelihood of the occurrence of the danger, exposure, and vulnerability. At the same time, the risk of loss and damage to infrastructure facilities in the event of an incident during the year can be determined as presented here, where PTI is the likelihood of the ITH incident with losses for the infrastructure facilities of the particular region. VTI is the vulnerability of infrastructure objects to destruction or damage from the ITH incident. NTI is the number of destroyed, damaged infrastructure facilities during the ITH incident. NTI is the total number of infrastructure facilities in the region. In EU countries, it is recommended to use a 5.5 risk matrix to visualize the assessment results when conducting national risk assessment for critical infrastructure. In this research, the risk of direct infrastructure losses from missile and artillery strikes at the regional level was assessed according to the data of the Kiev School of Economics and the Ukrainian Helsinki Human Rights Association regarding the losses of various types of infrastructure and the volume of missile and artillery sharing in the regions of Ukraine. The assessment results show that for almost all regions of the country, there is a risk of damage to the infrastructure by Russian artillery is sharing. At the same time, the highest level of risk of infrastructure losses from missile and artillery fire in the regions of Ukraine is noted in the Kharkiv and Donetsk regions. A high level of risk is characteristic of the Zaporizhzhia, Lugansk, Kherson, Chernigiv, and Mykolaiv region. The average level of risk of infrastructure losses from rocket and artillery fire is noted for the Kiev, Dnipropetrovsk, Sumy, Odessa, and Zhytomyr regions. At the same time, the likelihood of dangerous events and the possibility of economic losses from them are calculated based on the statistical data. On this basis, the corresponding dependency is formed, which was done to solve the purpose of this publication. The assessment results indicate that residential building, infrastructure facilities, the energy industry, and the agricultural sector are characterized by the greatest likelihood of infrastructure losses in Ukraine. At the same time, residential buildings, infrastructure facilities, enterprise assets, and industry are characterized by the highest likelihood of sharing. Considering the result obtained in the assessing the likelihood of missile and artillery attacks and losses of various types of infrastructure, the model constructed a risk matrix. It should be noted that the high risk of direct losses is typical for residential building and critical infrastructure facilities, assets of enterprises, industry, agriculture, education, and energy have an increased level of risk. Objects of the forest fund, trade, housing, and communal services, culture, tourism, sports, and transport have an average level of risk. When making management decisions regarding reducing losses of various types of infrastructure from sharing, it is evident that the primary attention should be directed precisely to preventing and reducing risk for residential buildings and objects of critical infrastructure. In the conditions of military operation and complex interactions of the main factors for formation of threats to infrastructure, an effective risk reduction process will involve the combined implementation of several scenarios, which may include strengthening their protection and duplicating their vital functions. Prospects for the further exploration in this area are mainly related to the complete estimation of losses of infrastructure objects from Russian military aggression against Ukraine, carrying out on this basis risk assessment for Ukrainian infrastructure objects of various types at the regional and national level, categorize them by types and levels of risk, and develop reasonable measures to prevent threats with large-scale negative consequences for critical infrastructure facilities. Thank you for your attention.
Hello, my name.
Thank you for your presentation. Dear colleagues, do you have any question?
Yes, I have one.
Yeah, please.
Why you consider separately critical infrastructure and energy, for example? I think that energy is an element of infrastructure of the country.
Yes, we include energy objects in our research. We have some information about the damage to energy infrastructure objects, and we have included in our calculations of the risks for various types of infrastructure. It's included in our research.
No, I mean in your presentation, in the table of the experimental results, you show separately infrastructure, critical infrastructure, and energy. Why?
It's because we have official information about damage to various types of critical infrastructure objects that was presented from Kiev School of Economics. So we included that type of information in our calculation and presented
Okay.
them as it is.
Okay, what does it mean critical information in this case?
Critical infrastructure, you mean?
Yes, critical infrastructure, sorry. What types of activity belong to critical infrastructure?
No, it included this. I hope that, I suppose that this term was presented in the slides, but I can repeat if you want.
Okay, thank you.
Any
I
other
have-
question, please?
Yeah,
please.
Do you use in your research element of instance infrastructure which was attacked twice?
No,
we
my
have these
answer.
examples.
I understand the question, but unfortunately, we don't have such information from official resources, and we have used information about official sources, and as far as I know, such type of information of what you asked were not presented in their statistics.
Why? Darnitskaya KPP. It was attacked twice.
Yes, but our research was connected with the time of between 2022 and 2020 end of 2023. So we have information during this specific time.
Thank you very much.
Dear colleagues, any other question? Any comments? I have one little question. Can you highlight more the future direction of your research?
Our research connected with the law of Ukraine, because in accordance with the law on critical infrastructure, the state policy in the field of critical infrastructure protection is based on the principles of creating conditions and implemented various measures aimed to reduction and control of security risks. And our research is directly connected to the control of security risks, because it directs some steps to reduce the risk of realization of possible threats and minimization of consequences of realized threats, crisis situation, and other types. So I think that our research is directly connected with the implementation conditions of law of Ukraine on critical infrastructure in these conditions.
Yeah, please.
Who is consumer of your research results or potential consumer?
Potential consumer could be the National Security and Defense Council of Ukraine, because it's very important part of research connected to the critical infrastructure protection, directly have impact on economic, environmental protection, national security at all.
Thank you.
Thank you, dear colleagues, for your discussion. And now we go to the next presentation.
Hello, my name is Olena Urbanenko, And today I want to present to you research infrastructure of decarbonization, digitalization and decentralization dealing renewable energy sources. Implementation of decarbonization, decentralization and digitalization strategy responds on main milestones of renewable energy sources and highlighted in National Plan development country. Also in our national plan, Rebuild Ukraine noted to development renewable energy sources. Research infrastructure dealing Green Deal developed last years and existed research infrastructure try to find new approaches in battery storage system, hydrogen technology, some innovations, agrivoltaic and so on. Vision and mission, future research infrastructure dealing with decarbonization, digitalization and decentralization are enshrined in Green Deal. 3DRS will develop strategy and business plan that can accelerate process to integrate to European research infrastructure. If you want to apply for any grant, for example, Horizon grant, cost grant or so on, it is necessary to create consortium. And policy in our research infrastructure must be similar or equal in policy and regulation document other university that we can be or other research infrastructure that we can to be real equal member or equal player. The 3DRS project can be started in creating a public organization united to create an integrated center for delivering the renewable energy sources sector. Mission on this research infrastructure leveraging development capacity 3DRS to accelerate the development of the decarbonization, digitalization and decentralization of energy industry and energy community is one of mission 3DRS. So also mission can to have technical decreasing of risk in growth reputation, research infrastructure, implementation energy efficiency industry, clean energy, pride and belonging, rigor and scientific integrity. So we must on the one table to see education, industry, business, government, and so on. So after analysis for whom it can be interesting and clarify my stakeholders, we can to find 4 more important pillars. I didn't see presentation.
Me too. I think that it's a
I
problem
haven't
with
seen the
power
presentation.
supply.
Oh, if you want, I can to. If you allow me, I have this presentation. I can prolong live.
Just a moment. Just a moment.
Something wrong with electricity, isn't now?
Quality metrics and standards. Value 3DRS for us. It is collaboration and sharing of knowledge, excellence in performance, renewable energy is available for everyone, high energy efficiency industry, clean energy, pride and belonging, rigor and scientific integrity. So we must on the one table to see education, industry, business, government, and so on. So, after analysis for whom it can be interesting and clarify main stakeholders, we can find 4 more important pillars: research, industry, education, government. And just networking for this pillar give us really efficient research infrastructure. Pestle analysis can help us analyze future our research infrastructure. So, if you speak about politics, it is new policy in wartime, which help us operate research infrastructure. If you speak about economy, it have like positive, so negative impact. Likely impact of tech progress, super. High level investigation if renewable, also good, but high level inflation green or for other can to be problem. Society at high level popularization, renewable energy, green energy, education, change lifestyle and so on. About technology, it is fastly increase renewable energy sources also requires to additional study. So how to implement, how to operate, how it's worked. About environmental, it is green transaction, digital transaction, green consumption, and about law, it is ERIC regulation. It's need to find how it's working European Union and try to adapt to in Ukrainian law or Ukrainian law to create with take to account normative document. So, SWOT analysis may be more useful than the PESTEL because also help us to find weakness and threats. So, just to stop about strengths, it is created power consortium receive European Union grants, access to data of member, access to of equipment stakeholders, forming of powerful team and so on, information support. Yes, it is giving us a lot of opportunity because we can to create power consortium and receive grants, access to data of members, access to equipment of stakeholders, and forming of powerful team information support. So very similar exactly with strengths. But if you speak about weakness, it is absence clear policy and legislative for ERIC, low level popularization, high level of dependency. If you speak about threats, it is absent one general legislative which will work for potential countries member. Traditional energy is cheaper. So there is ideas will take long time and finance. So in this case, very important to find more relevant KPI performance indicators just to clarify with really which we work, what index is important for us. So common project, exactly yes. So we want to create powerful consortium. And in this case, KPI number of common applied projects, owners, CDRS board, measures, number supported projects, number applied projects, report and presentation for stakeholders, and check efficiency 3DRS. I am give this measure like some relation with number supported projects and number applied projects. Very important to have high level this index because if you're applying a lot of projects without any winners and successful, your team start to be like deep crisis, and it is important to find good motivation. So the presented paper shows result of development research infrastructure dealing with decarbonization, digitalization and decentralization renewable energy sources. Right now it is topic very popular and important because renewable energy sources and decentralization renewable energy sources is one of the way how to meet our energy independence. 3DRS would collaborate European level, national level, business level of energy industry, education sector, university and research institutes. So, main goal is to create the ERIC, European Research Infrastructure Consortium, is sharing of developed innovative investigation and service for stakeholders. 3DRS will be created for helping researcher. One of these good examples in Darian. So they don't work exactly with renewable energy sources, they work more with art, but very good build strategy and very successful. Proposed to study strategy is new for Ukrainian scientific ecosystem. For development of 3D strategy, it builds 6 pillars of marketplaces as a digital platform and national research nodes. We don't have any national research node dealing with renewable energy sources. And if to be honest, it's not exist in high level, it's not presented in high level in Europe, because everything is dealing with sustainable development goals have other priorities. So biological, as for measurement, for medicine, has a lot of technical, for example, CERN has Eric more dealing also with some biodata or other measurement with cultural, but not so much work with renewable energy sources. 3DRS approaches specific network and education strategically. 3DRS will coordinate visions and deepen connection to industry, science institute, educational university, municipality, communities, and ensuring they want to support Green Deal and implementation renewable energy sources and strengthens our voice in policy and advocacy. So, this research is dealing with Arizona project. 9 participators from Ukraine was voted in 2022-2024 years, 2 years education, and receive financial support for this education from European Union just to study for management research infrastructure in Bikoka University. This research have one assignment wasn't presented in 2022 years, but we take into account current situation and just to find new view for creation national node dealing in renewable energy sources in Ukraine. So if you have any question, don't hesitate to ask me. I am happy to answer.
Thank you for presentation. Dear colleagues, do you have any question? If nobody have question, I have some question. Can you explain the significance of integrating decarbonization, digitalization, and decentralization, known as the model in renewable energy strategies, and how these pillars contribute to the resilience and sustainability of energy system?
Yeah, thank you so much for your question. And what about this project? That in Ukraine, we still didn't have any national node dealing with renewable energy sources, but we have a lot of so much universities, research institutes, also every enterprises, for example, NES or other, has R&D center, but they don't work together. And also we don't work with power supply company, for example, Oblenergo. But what is problem? Everybody from this area, this institute, include non-government organization also, must to collaborate. And if we create some assets, some national node, what can to cover all of them with strong support government, we can to be more useful. So in this case, research will be for industry, education for industry, for example, for government or for non-government organization. Other benefits, it is experience other country. Example, one of the biggest ERIC, European Research Infrastructure Consortium, it is CERN. CERN knows everyone. So in this case, I not propose to create CERN in Ukraine, but I propose to create in Ukraine research renewable energy sources node, because it's still not exist in Europe. So why not why create this in Ukraine? We have all we have all renewable energy sources potential: wind, solar, hydro, bio. No, because we simply have this meteorological condition. Our our place, our location. And it is also about energy safety, because distributed decentralization. Decentralization, it is about energy safety, and nobody want to attack a lot of distributed power sources. It isn't simply not good for it. It's not, don't have so big benefit. Right now, if you listen, Andrei Zinchenko, he is chief of energy cooperative, I think in Slavutir city, say that maybe it's okay that owners photovoltaic power station start to be prosumers and also help to balancing system in when we have some attack time and some problems. So why not? So it is for stability, it is for energy safety, it is for collaboration, and it is also for where find money. One of the way find money, it is create good consortium, because Ukraine still didn't have directly possibility to receive money from Horizon 2020 program, just like part or like sub-grant. Okay, if it's a grant, we just to have what main benefits are received and can to give us like what we have. It is little part. It is not possible to build so huge research infrastructure just in this case. But if we create consortium more than 7 members, it is more, how to say, it will give us more guarantees and we receive Horizon grant. I say that it is not possible, but still exists a lot of grant just rebuild research infrastructure. It is not easy to catch this grant, if to be honest. It's very strong competition and not a lot of it's really difficult to create good consortiums that everybody will interested. And if to be honest, in Europe, ERICS, really powerful ERICS 6, 7, not so much. It is good and bad. Good. They really wanted to help us, but they don't work with renewable energy. So they simply don't understand correctly thematics, topics, and more concentrated for innovators, for art design, for artificial intelligence, Marianne, no, some simply other. In Czech Republic, it is free. No, Eric would exist, but all of them biological, not renewable. So our benefits, it is safety, it is networking, collaboration, approach to together participate in cool grant, because most stakeholders, not so big risk. Thank you for your question.
Thank you so much for your wide answer. Yes,
one-
one short question.
Okay. Could you tell me a few words about energy storage systems for renewable energy? It's very important part of this system, but we have a very different way for development of it.
Yeah, so it is depend what you think about storage system, because here you have two ways. If you speak about energy storage system, everybody first to think it is battery system, but really need to think about efficiency. Example, in NES, in Vinnytsia, NES region, they 3 or 5 years speak about that, create super battery storage system, 1 megawatt, and start to propose on the market service that we can to keep your electricity and to sell. It is good, but all storage system, all time we speak about first lifetime, second it is power losses. Other possibility, what is create a power supply company? Yeah, it is create exactly Yuri Petrovich Kasic. He is chief, but previous to start to be chief of Opelenерgo, he works dealing with hydropower system. So they, for stability, 2 last years create some test like local energy system. So they use hydropower plants to like usually to use, and I think in Soviet Union time also, to have a pumping system, so they storage water, and to in the time when they don't have power supply to share. And they have some tests just to create local system, 5 local system near this hydropower plants, and also in this area exists photovoltaic power system. Photovoltaic power system cannot work without hydropower plants in these hydropower plants. So they have some problem with power quality. Okay, what mode must to be used? Power generate, synchronous generators or synchronous generators, more technical questions. So in this case, we can work in like two directions: battery storage system classical, or second, I don't speak about hydrogen or some innovation, or like old method use also hydropower plants, but need to correctly calculate it mode.
As
Thank
I
you for your answer.
understand, as I understand, supercapacity energy storage is not economically effective.
It is expensive, and when we design photovoltaic project, for example, when you use PV sol or PV system, you have all lifetime of elements. So if we speak about photovoltaic models 30 years, inverter 15 years or 10 years, and if we speak about battery storage system, it's not so big. So it means you must to
5 years.
this. Yes,
5
so
years.
it is expensive if you speak about classic battery storage system.
Okay.
Very interesting discussion, but we must
Thank you very
move
much.
Yes,
to the
we
next
can be in
presentation.
contact, so
Thank
don't
you, dear
worry.
colleagues. We have chat for the future discussion, and now we must move.
Okay. Good morning, good afternoon, good evening, dear colleagues. My name is Yuri Krylenko. I work as head of the laboratory on radiological assessment and dose projection of State Scientific and Technical Center for Nuclear and Radiation Safety. I'm also a member of the Emergency Center of the Ukrainian regulatory body. So in my presentation, I would like to stress the issue of resilience of system for public protective actions under wartime. I'm going to give general view on the in-between experience and challenges faced during the last time. The main tasks of SEnW include comprehensive technical and scientific support for the regulator in nuclear and radiation safety issues at all stages of nuclear facility life. In the context of emergency preparedness and response, our organization is involved in the activities of the Information and Emergency Center. Our experts participate in the development of the regulatory framework, emergency planning, and radiation monitoring activities. Since full-scale invasion, our experts provide analysis of potential accident may be occurred at Ukrainian facilities. The main task for radiological assessor in case of emergency is a real-time assessment on recommended protective actions for the territories controlled by Ukrainian government, as well as for the territories temporarily occupied by Russian troops. So let's have a look at the general concept of emergency preparedness and response for a peaceful time. There are preparedness stage and response phase separated by declaration of the emergency class of event. In war condition, the concept does not work. Preparedness and response stages are mixed. We have some time before the potential event to prepare additional data, source terms, statistical calculations to provide approximate area affected by the release. Since March 2022, Emergency Center of Ukrainian regulatory body has been activated several times. During the activation, calculations for Zaporizhzhia nuclear power plants were provided on a regular basis. Using special software, we defined the area could be affected by protective actions. In this slide, some calculations conducted in 2022 using European decision support system JRODOS. Now I'm gonna list the main challenges faced for the past 2 years of full-scale war. First of them relates to accident scenarios should be considered in such non-standard conditions. Also, it calls reference scenarios. In this slide, you can see some example for Zaporizhzhia nuclear power plant. Obviously, events considered in design or safety analysis reports cannot consider external hostile actions of enemy. Therefore, the list should be extended based on current situation, expert view, and any other available resources. In frame of this slide, I should mention the set of reference scenarios is not stable thing. Since full-scale invasion has been changed and modified several times. Second one is optimization approach often used for urgent protective actions. As an example, for evacuation, we should conduct optimization taking into account a lot of factors such as number of people to be evacuated, availability of vehicles, preparedness of evacuation sites and roads, etc. Basically, we know how to do it in peaceful time, but in wartime, we should also consider occupied territories and associated risks for Ukrainian public due to Russian troops. Another challenge will put us to such measurable quantities like operational intervention levels. Such levels in terms of, for example, dose rate are developed with the aim to justify the implementation of protective actions. In preparedness stage, oils should be established based on possible events considered in the design of the facility. But in case of Zaporizhzhia nuclear power plant, the power unit is in non-design status regarding shutdown mode around 2 years. Thus, the expected measurable quantities should be harmonized to the reference accident scenario, considering the current isotopic content of the reactor core or spent fuel pool. Fourth challenge relates to data simulation. Generally, this is procedure of combining the modeling results and the first measurements obtained from monitoring station. In light of the Zaporizhzhia nuclear power plant, this issue becomes extremely important because there is no direct connection between regulatory body and the facility. Indeed, with a possible wind direction to the right bank of the Dnipro River, the first markers for assessing the release and the situation in general may be the dose rate values obtained from the nearest monitoring station. And the last but not least, existing emergency planning zones around Ukrainian facility has been developed based on events in some range of probabilities. When we talk about war condition, regarding the experience received from Zaporizhzhia site capture, planning zone can be promptly reassessed using reference accident scenarios and statistical weather data. It means we can respond to current status and current threats and provide additional resources. For example, distribution of iodine tablets to some region of our country, like it was in 2022. However, how often we should do it during the war is still open question. To sum up, looking at the 2-year experience, we can try to highlight very preliminary points on the topic. Preparedness for an event that may be happened as a result of hostilities requires more knowledge of the response of facility system and elements to potential military threats. The range of potential consequences for the public should be narrowed based on expert opinion, current status, or possible nature of impact on the nuclear facilities. Existing response mechanism and procedures should be supplemented with special response procedure in war conditions. And finally, creation of a secure virtual platform for expert communication may be the best solution to ensure the emergency response system resilience in wartime. Thank you for your attention.
Thank you, Yuri, for your presentation. Dear colleagues, one short question because we must move to the next presentation. Yeah, Sergey, please.
In context of your report, I would like to find out the meaning of term resilience. What do you mean?
Yeah, I totally understand your question. In our study, we have just some kind of review, some kind of qualitative analysis because as for now we have now provided any quantitative measures in resilience, but in our work we were trying to focus on the gaps that we have in public protection system in wartime. So in future we can reflect it in some measures. So yes, in this case, it was just a qualitative analysis.
As for me, I think that resilience consists of two parts, adaptive and restore the system. And I think that your report devoted to the problem of the adaptive, of the period of the adaptive of the system to the future dangers or risks. Is it correct?
Yeah, because we cannot restore our state like for peaceful time because this is a wartime. This is another risks. This is another resource that we have. So yes, we should adapt to the situation. So this approach is only adaptive.
Thank you.
Yeah.
Dear colleagues, thank you for your discussion. You can continue in chat, but now we must move to the next presentation.
Hello everyone, for your attention here is a presentation on prospects for autonomous low power renewable energy communities by Yuri Veremichuk, Vitaly Opryshko, Ivan Pritiskach and Olena Yermoluk from National Technical University of Ukraine, Igor Sikorsky, Kyiv Polytechnic Institute. In this presentation, we will provide an overview of Ukraine's renewable energy landscape, outline our mathematical modeling approach for renewable energy communities operation, present results on achieving renewable energy communities autonomy through capacity optimization, and discuss implications and recommendations for fortifying energy autonomy. In Ukraine's energy landscape, renewable energy sources are on the rise, notably solar and hydropower. Solar power plants, particularly in the 10-50 megawatt range, dominate the market, followed by smaller plants between 5 and 10. Wind energy lags due to the high cost and complexity. Small-scale producers mirror this trend, with solar power plants leading at 122 megawatts, followed by small and micro hydroelectric plants at 47 megawatts. Across capacities, solar power plants dominate, followed by mini and micro hydroelectric plants. Ukraine's energy reforms prioritize distributed generation, aligning with the European Union's directives. This study aims to optimize small renewable energy sources plants, enhancing energy security and autonomy, with further research focusing on modernizing energy system for societal and economical benefits. As the energy sector in Ukraine undergoes significant reforms, there is a compelling need to cultivate distributed generation and align with the principles of the European Union's fourth energy package. This has paved the way for the emergence of renewable energy communities as a contemporary decentralized solution. Our research aims to address three key objectives. First, we explore strategies to ensure the autonomous operation of renewable energy communities. Second, we delve into sustainability of this autonomous system, particularly during conditions of autonomy or blackouts. And third, we focused on optimizing existing hybrid power systems that incorporate diverse renewable energy sources such as solar, wind, hydro, and biogas. Ultimately, our overreaching goal is to devise strategies that fortify Ukraine's energy security by maximizing the potential of renewable energy communities and hybrid system, thereby reducing dependence on centralized network and fostering a resilient decentralized energy infrastructure. This model on the slide encapsulates the operational dynamics of low-power hybrid renewable energy systems, considering mode characteristics of generation sources, a set of objective functions, and technical and economical constraints. The model facilitates optimal load distribution among system components. Addressing the complexities associated with a solving optimization problem or making optimal decisions involves overcoming significant challenges, with a key difficulty being the conceptualization of a reasonable optimality principle. For multi-criteria decision-making problem where the concept of vector optimum is not defined, there is no singular optimality principle. The only viable approach to tackling this challenge is to narrow down the Pareto region. Recognizing the multi-criteria nature of the optimization problem, we employed the Bellman-Zadeh method, grounded in principles of fuzzy set theory. This method offers several advantages. First, it allows for the simultaneous consideration of quantitative and qualitative factors with the ability to distinguish their relative importance. Second, it provides a clear and logical definition of the optimality criterion focused on maximizing the achievement of all target functions. And third, it guarantees that the solution obtained belongs to the Pareto optimal region, representing the most harmonious solution. Through the iterative process, the method derives a fuzzy solution, which is then diffusified by selecting the alternative with the highest degree of membership, representing the optimal decision. By incorporating this robust multi-criteria decision-making approach, our methodology aims to strike a balance between reliability, cost, and environmental considerations, ultimately optimizing the operation of renewable energy communities for enhanced energy autonomy and security. To evaluate the feasibility and implications of achieving autonomy for renewable energy communities in Ukraine, we conducted simulations across 4 distinct renewable energy sources communities. These structures were delineated by varying the ratios of installed capacities among different types of generation sources, namely solar photovoltaic plants, micro hydropower plants, and biogas plants. Our first set of simulations explored the scenario of achieving autonomy for the renewable energy community by augmenting the installed capacity of biogas generation. We conducted simulations with variations in the installed capacity within the range of 50% to 200% of the current capacity levels. On this slide, you can see the optimal loading profiles under the initial conditions where the community relies on the external grid to meet a portion of its energy demands. In contrast, this slide depicts the optimized operation mode under the conditions of achieving autonomy through the increased installed capacity of biogas generation. This mode ensures that all the consumed electricity is generated within the community, eliminating the need for external power flows. These results underscore the significant capacity investment required to transition towards energy self-sufficiency, especially for communities with a large reliance on biogas generation. Next, we explore an alternative scenario to achieve autonomy by augmenting the installed capacity of solar photovoltaic plants within the renewable energy community structures. Our simulations involved varying the installed solar capacity from 150% to 500% of the current levels, and here are the results of our finding. However, similar to the biogas scenario, our results indicate that autonomy remains untenable for the type 2 and type 4 structures, even with a 500% increase in the installed capacity. This slide displays the optimized loading profile under the initial conditions where the community relies on the external grid to supplement its energy needs. In contrast, this slide showcases the optimized operation mode after achieving autonomy through the increased installed capacity of solar generation. This mode demonstrates how the community can meet the entire electricity demand slowly through its own renewable energy sources without drowning power from the external grid. The results from our simulations and optimization analysis shed light on the feasibility and implications of achieving autonomy for renewable energy communities in Ukraine. While these capacity increases may seem daunting, it's essential to recognize the potential benefits of achieving energy autonomy through resilient renewable energy communities by reducing dependence on centralized networks and maximizing the utilization of local renewable sources. These communities can enhance supply chain reliability, bolster regional energy security, and foster local economical growth. In conclusion, our research has shed light on prospects and strategies for achieving autonomous operation of renewable energy communities in Ukraine, aligned with the ongoing energy sector reforms and the transition towards decentralized resilient systems. Through rigorous simulation and optimization analysis, we have demonstrated that attaining energy autonomy for certain renewable energy sources community structures is indeed feasible, albeit requiring substantial increase in installed generation capacity. And thank you very much for your attention.
Thank you for your presentation. Dear colleagues, any question?
I have one.
Yeah, please.
When we talk about the modeling of the development of the capacity of especially solar and wind power plants, it is necessary to take into account unpredictability of the production of electricity from these type of technologies, using this type of technologies. And when we consider the consumption of electricity is not a good approach, is not because it is necessary to consider the residual consumer of electricity determined as the difference between the total consumer, the final consumer of electricity, and the electricity produced by solar and wind power plants. And this residual consumer is the graphs that must be covered by controllable electricity producers, such as electricity storage systems, nuclear power plants, and so on, and hydropower plants, and so on. And when we understand the importance of unpredictability, we must dramatically change your methodology, your model. And this model, the similar approach, leads to create new German electricity system. In this system, more than 70% of electricity produced by solar and power plants. And this is the strong problem in electricity of Germany, of modern Germany. For example, 5 months ago, the electricity on spot market in Germany lost $50 billion during the 10 hours, only 10 hours, minus $50 million. Please find out the specific of working similar energy systems and develop a mathematical model taking into account unpredictability of the producing electricity by solar and power plant is very important factors. Thank you.
Yeah, thank you for your comments and questions here. In our modeling, there was some controlled power sources and uncontrolled power sources. As you say, the solar power plants is uncontrolled sources, and it has definite unpredictability, which depends on weather conditions. And but this energy community also includes controlled power sources such as hydropower plants and biogas generation plants, which can be changed their power generation during different hours of the day. And yeah, but the unpredictable nature of the solar generation was taken into account by getting some average values during the for this specific region. And yeah, we definitely will work on to improve the model, taking into account the possibility of including wind power generation, which also has unpredictability as the solar generation, and like to find some reliable way to include the information about possible unpredictability of the solar and wind generation to get the more reliable and accurate results. Thank you.
Okay, and what is the methodology we used in order to take into account unpredictability of producing the electricity from solar and wind power plants?
Yeah, we have we can gather some statistic of this values of solar and wind generation for the different regions, and even when we know the specific region, we have like some average values of the generation and the uncertainty of these values during different hours and different
I'm sorry, does it
period.
mean,
Yes.
I'm sorry, does it mean that we use the statistical model?
Yeah.
Okay, and when we use the statistical model, you cannot possibility to take into account the restrictions of maneuverable of power produced by controllable technology, by controllable power station. It's significant factors that you cannot correct into account. I repeat this question one more. It's not correct methodology to approach, to predict, to forecast the development of the renewable power sources together with the controllable power plants and in one system. It's a serious problem for modeling of the development of power plants now, not only for you, but totally. Thank you.
Okay, yes, I think we can work more on this in other future works.
Dear colleagues, thank you for your
One
discussion.
short remark.
Short, please, short. One.
I think your methods could be effective used for household energy supply system. Household. It's quite effective.
Yeah, we are aiming not to not to very power like the level of the power system is not very much, like for example up to 1 megawatt of power, but yeah, I think it can be effective for the small system like in households.
Dear colleagues, thank you for this
very much.
discussion. We must move to the next presentation.
Dear ladies and gentlemen, your attention is offered a report on the topic comparative analysis and modeling safe variability areas of power for the VVR 1000 and AP 1000 power units. My name is Sergei Sauch. I am Doctor of Science, Professor, Correspondent Member of the National Academy of Sciences of Ukraine. This overview discusses the challenges and opportunities associated with integrating renewable energy sources and nuclear power into modern energy systems. It covers topics such as the operation flexibility of nuclear power units like VVR 1000 and AP 1000 methodologies for modeling power system dynamics and the mathematical descriptions of nuclear power units in the energy system models that prioritize high levels of the renewable energy supply and demand while transitioning towards a more sustainable and resilient energy infrastructure. The penetration of large volumes of uncontrollable electricity generation from renewable energy sources, from solar radiation and wind, leads to the need to use controlled electricity generation in the power system in volumes sufficient to balance demand and supply. The presented graphs of the residual daily electricity consumption in the summer and winter of 2021 actual data and 2050 forecast data show a significant increase in demand for the maneuverable power of nuclear power units, provided that the share of renewable energy source increases from 7% to 30% respectively. The question arises, with such a perspective of power system capacity development, will it be possible to balance their load modes with existing and promising nuclear power units VVR 1000 and AP 1000 respectively? The power change parameters of the VVR 1000 provided in the technological regulations are justified in the project and regulated based on the requirements of safe operation of the reactor and the conditions of operation of the power unit in the basic mode and an almost constant level of thermal power. At the same time, the design of the VVR 1000 reactor provides for a list of modes that are currently not used in the operation of the nuclear power plant power units and are not included in the list of permitted modes in the technological regulations for safe operation, but can potentially be considered acceptable for implementation under the conditions of experimental confirmation. Comparative analysis of the AP 1000 and VVR 1000 shows a more flexible algorithm of AP 1000 operation in daily power regulation, which can be described by the scheme 18222 instead of 12363 for the VVR 1000 during 19% of the fuel campaign, and the actual absence of reactions on the need to ensure the dwell time over the entire range of reactor power changes. Comparison of design characteristics of VVR 1000 and AP 1000 power units are presented here. Usually,
the load regimes of nuclear power units are determined by a priori determined load schedulers, which significantly limit the adequacy of the representation of the maneuvering properties of such power units in power system models. We offer a mathematical description of the areas of safe loading and power maneuvering of nuclear reactors for an adequate representation of their maneuvering capabilities. Let us denote the relative power N and present its rate of change in the form of a function f, which depends on the value of N. We will present relation 2 in the form of a differential equation 3 with distributed variables n and t. We will write the latter in the integral form 4, which will be used later. We will present the tabular characteristics of the power variability of nuclear power units in the form of the step function 5. Substitute this function into the previously obtained integral equation 3 and obtained algebraic equation 7, in which the f functions marked with the capital letter are the original functions of the f function marked with the small letter. Solving equation 4, 8 with respect to delta n for various values of n and with fixed time intervals delta t, namely 10 minutes and 1 hour, yields characteristic depicting the maximum rate of increasing in thermal power of VVR 1000 and AP 1000 power unit reactors from its current value. These characteristics are presented here. The characteristics obtained reflect the power unit's capabilities to operate safely during maneuvering modes. The areas of safe maneuvering with the power of the AP 1000 power unit are much wider in a comparatively larger range of its loads. It is essential to incorporate conditions of safe loading and power maneuvering for the VVR 1000 and AP 1000 power units into dispatching models and electric power systems and planning tasks for their development. We define the following conditions for the AP 1000 power unit. They are presented here in the form of a system of restrictions, both on the amount of power and on its decrease or increase during the time period delta T. The mathematical distinction of the area of safe maneuvering by the power of VVR 1000 power unit is more complex. The upper limit of the rate of increase in power is a piecewise linear function depending on the temperature delta T. Here, the alpha and beta coefficients are used. The calculated values of this coefficient are presented in the following two tables for time steps of 1 hour and 10 minutes, respectively. The resulting systems of constraints serve mathematical models representing safe maneuvering areas of AP 1000 and VVR 1000 power units. These models are specifically designed to accurately capture the characteristics of safe maneuvering regarding the power output of both existing and promising nuclear power units. They are intended to be utilized in tasks related to planning the development of electric power systems with significant shares of electricity production generated by wind and solar power plants. Thank you for attention.
Thank you for your presentation. Dear colleagues, do you have any question? If I don't see any question, so I have one question. Could you discuss the practical implementation of your research for the future development and deployment of nuclear power units in Ukraine, especially in terms of ensuring flexibility and reliability in the context of an evolving energy mix?
Thank you for your question. When we're talking about the development or planning the development of electricity system, especially in Ukraine with a higher level of nuclear power units, including in production of electricity, it is necessary to take into account the specific of the traditionally using model of the electricity power system, similar as in Ukraine, and the possibility to correct prediction of the development of this system. And I must to say that now in the world there is no the model that can be adequately presented the maneuverable characteristics of nuclear power plant, and as a result we observed the antigency between the development of the nuclear power plant and the renewable energy sources. As a result, we can see on the traditional, using the traditional model, we can see that it is necessary to develop renewable energy sources, and it is necessary to develop nuclear power plant, and it's enough to build the system from the solar and the wind power plant and include the accumulator energy storage system, and it's enough. And we build the future with pin glasses, everything green glasses. But it's the result of I talking today about unpredictability of the unpredictability of the production of electricity from renewable electricity sources, and also it's a problem on adequacy presented the potential ability to change the electricity production from nuclear power plant. but we must remember that there is a country such as France with a high level of electricity production from nuclear power plant, and they have a good experience to variability or using the variability of the nuclear power plant and technology. And it's very important to guarantee the safety of this operation with nuclear power plant. But when we talk about the development of nuclear power plant in Ukraine, it is necessary to take into account the characteristics of maneuvering of thermal power of reactors, and depending on the type of reactors, these characteristics is more significantly differ. And for example, the small module reactors and micro module reactors have significantly more wider characteristics, and those nuclear power unit that using in Ukraine. And proposed the modeling, include in the model of electricity power system the restrictions that characterize the maneuvering ability of future nuclear power units is very important, because when we take into account these constraints in the model, it's significantly increase the adequacy of our forecasting of the development of the electricity power system. It's a new model. Thank you for your questions.
Thank you for your comprehensive answer. And now we must move to the next presentation.
I am glad to warmly greet the organizers and participants of the conference. The topic of my presentation addresses key challenges in ammonia production in Ukraine. 4 materials rank highest on the scale of necessity, forming so-called the 4 pillars
Some trouble, excuse me.
modern civilization. Cement, steel, plastics, and ammonia are needed in larger quantities than other essential inputs. They collectively use 70% of energy generated, and their production relies heavily on fossil fuels. But it's ammonia that deserves the top position as our most important material. Its synthesis is the basis of all nitrogen fertilizers, and without their application, it would be impossible to feed at the current levels approximately half of today's nearly 8 billion people. It is how we could reduce the impact of ammonia production in Ukraine without cutting it out of our lives. After the war, a favorable situation may arise in Ukraine, not only for restoration of ammonia production, but also for its increase, and the implementation of new state-of-art technologies that make it possible to improve energy efficiency and reduce carbon dioxide emissions. The main objective of the paper is analyzing the prerequisites for post-war ammonia production in Ukraine and developing an optimization model to minimize primary investments in the quantitative and qualitative development of ammonia production in Ukraine. 5 big industrial plants could produce ammonia in Ukraine. Only 2 are in operation now due to the wartime. In September 2021, the plant in Odessa has stopped the production of chemical products due to the high natural gas price in Ukraine and the low price of ammonia on the world market. The plant in Severodonetsk was blocked due to hostilities. From 2014, concerned Stirol is located in the temporarily occupied territory and does not produce ammonia. The annual ammonia production capacity totals approximately 5.7 million tons. It should be mentioned that besides the ammonia production capacities, nitrogen fertilizers production facilities also exist in Ukraine. The shortage of fertilizers on world market leads to an increase in their cost, reaching the highest level since 2020. Another advantage for Ukraine is the presence of a large branch system of gas pipelines and preserved wells. That is the necessary infrastructure for carbon storage and capture. Ukraine has an 800-kilometer ammonia pipeline, Horlivka-Odessa, with a capacity of up to 2.5 million tons per year and a significant fleet of railway and road tankers for transporting ammonia. Ukraine is one of the largest exporters of food. During the wartime, food and agricultural products remained the largest part of Ukrainian exports, accounting for 53% in 2022. After the wartime, Ukraine will need fertilizers to provide intensified agricultural development. Ukraine would have an advantage from the participation in the European Union emission trading system and a significant benefit from the export of ammonia, given the appropriate carbon dioxide emission factors. At present, the carbon border adjustment mechanism holds substantial implications for ammonia production, particularly in the context of the European Union ambitious decarbonization strategies. The authors have been developing a set of optimization models with different objective functions, primary investments, cost of ammonia production, carbon dioxide emissions, etc., different levels, national, plant, periods, implementation stage, life cycle period, etc. The authors have been developing a database of ammonia production technologies. At the present stage, this database includes the following technologies: steam methane, auto recovery, autothermal reforming, carbon capture and storage, and electrolysis. Techno-economic indicators of ammonia production technologies are presented in the table. At the slide, you can see the example of optimization model to minimize primary investments for reaching given ammonia production and specific carbon dioxide emissions. The results of the calculation for different production volumes restored before the war, 2 times increase and 3 times increase, and specific carbon dioxide emissions, the average in EU, and the benchmark for CBAM are given at the slide. The sharp increase in required investments is observed when new production capabilities are needed. For existing capacities that will be undamaged after wartime, the most effective mitigation measure, both economically and environmentally, is carbon storage and capture. For existing plants that will be damage after the war, it's necessary to estimate the level of destruction of each plant and make a decision about the expediency of restoring previous production technology or implementing new state-of-the-art technology. After the war, a favorable situation may arise in Ukraine, not only for restoration of ammonia production, but also for its increase and the implementation of new state-of-the-art technologies that make it possible to improve energy efficiency and reduce carbon dioxide emissions. The authors have identified prerequisites for the post-war ammonia production development in Ukraine. The authors have presented the optimization model to minimize primary investments for reaching given ammonia production and specific carbon dioxide emissions. The sharp increase in required investments is observed when new production capacities are needed. For existing capacities that will be undamaged after wartime, the most effective mitigation measure, both economically and environmentally, is carbon storage and capture. The authors have outlined the main direction of further study, development and clarification of the technology database, use of plant-specific data on energy consumption and emission factors, development of new optimization models, in particular, minimizing the levelized cost of ammonia production at the national level. Thank you for your attention. Please reach out with any following up questions.
Thank you for your presentation, dear colleagues. Any short question? Yeah, Oleg, please.
Hello, thank you very much for presentation. May I ask you, in your presentation you have mentioned the process of electrolysis, but in general, what are your thoughts about green hydrogen, which can be used in the process of creating the following green ammonia? Because currently in Ukraine there are projects in order to develop facilities to produce green hydrogen, like near such factories. What are your thoughts on that?
Вас не чути. Natalia, we don't hear you. Maybe you try to answer in chat. Please try to answer in chat, but now we must move to the next presentation.
Everyone, theme of presentation is chatbot application to support indoor temperature control. Natalia Kulikovska, Artur Timenko, Svetlana Hrushko, Vadim Shkarupila. The Internet of Things is one of the most promising areas of information technology development, which involves communication between various devices and sensors via the Internet. IT systems can collect, process, and analyze large amounts of data generated by these devices and use them improve people's quality of life, business efficiency, and environmental safety. However, in order for customers to be able to easily and conveniently interact with IT systems, intelligent and natural user interfaces are needed. Chatbots are one such interface that uses artificial intelligence and neural language processing to simulate conversation with people or other chatbots using text or voices messages. Chatbots can provide users with comfortable and efficient assistance by answering their questions, providing them with more interesting answers, directly responding to their problems. Furthermore, the article highlights the ability of chatbots to process the substantial amounts of data generated by sensors and IT systems, and they present this information in a format that's readily compressible and actionable for users. This study examines an IoT system comprising sensors, a code-based platform for data storage and processing, a database, and the chatbot interface to facilitate user interaction. Arduino boards are chosen for IoT devices. The Python development language is used due to its extensive libraries, support for data analysis, and easy of integration with IoT devices. PostgreSQL relational database management system is used to store temperature data. This technology provides robust support for SQL queries and can handle large data sets. The PsyCopy2 library is used to connect to the database from the cloud platform. The chatbot is written in Python. For the OMP module, the SPACE library is used, which offers advanced functionals for tokenization, recognition of named objects, and analysis of syntaxation dependencies. Python also provides pre-built models for different languages, which allow for faster application development. SPA-C can be used to analyze user queries, extract important objects, and understand the context to formulate meaningful answers. We can consider the algorithm of chatbot operation with IoT. Receiving a text command from a user, processing a text command using neural language analysis, next determine the action to be performed based on the processing of a text command, interaction with the storage system to obtain information about the temperature in the house, application of the temperature control algorithm to change the setting of the thermoregulation system in the house, update the temperature data in the storage system, and sending a response to the user with the results of the action performed. The chatbot was evaluated in a real-world scenario, tested within a hangar facility spanning 800 square meters. The environment was equipped with a variety of the IoT-connected devices, including temperature sensors, air conditioning units, window and door sensors to detect opening, closing, as well as a ventilation system, figure 1. During the test, the chatbot demonstrated its ability to autonomously maintain the temperature within the hangar, utilizing the air conditioning system to ensure the temperature did not extend to 32 degrees Celsius. The chatbot interface allowed users to interact with the system through text commands, enabling them to adjust the target temperature as desired, figure 2. Critically, the system incorporates control mechanism to monitor the status of window and doors as well as the ventilation system. Temperature readings were recorded at half-hourly intervals, providing the chatbot with the necessary data to intelligently regulate the environment. The autonomous nature of the chatbot's operation allowed it to proactively manage the temperature without constant human supervision. However, the system was also designed to provide users with a seamless interface or to directly manipulate temperature settings, overriding the autonomous control if necessary. The balance of autonomous operation and user interaction represents a key third of the chatbot-driven IoT solution. Throughout this real-world evaluation, the chatbot's capabilities were thoroughly tested, demonstrating its ability to effectively maintain optimal environmental conditions within the large hangar space, while also offering intuitive user control capabilities to accommodate specific user preference and needs. The system provides for critical situations, for example, an IoT temperature sensor failure or erroneous user command that can lead to a dangerous change in indoor temperature. Therefore, protection mechanisms have been implemented, such as automatic temperature change and notification of occurrences of the problem. This paper investigates the functionality of chatbots for indoor temperature control using Internet of Things systems. The paper analyzed modern programming languages used in IoT systems and considered the architecture and algorithm of the proposed system. The system integrates a chatbot driven by natural language processing with temperature sensors, air conditioners, and database. Users can easily use commands through the chatbot to regulate the temperature, monitor the current status, and receive notification of critical situation. The main components of the system and modules for a chatbot controller, IoT hub, and IoT sensors. The core of chatbot is the SPA-C library of the language processing. The system uses a Python programming language, PostgreSQL for the database, and AWS IoT core platform. The system has been successfully tested in the real-world environment of a large hangar. The chatbot has demonstrated the ability to autonomously maintain the desired temperature, interact with the condition system, and respond to use commands. The system also has mechanism to protect against critical situations, such as sensor failures or dangerous commands from users. The research demonstrates the potential of chatbots as an intelligent user interface for IoT systems, combining automated control and convenient human interaction. The development system is flexible and scalable, which opens the prospects for its future environment and implementation in various fields. Thank you for your attention. That's all.
Hello, dear colleagues.
Thank you for your presentation. Dear colleagues, do you have any question? Yeah, Oleg, please.
Hello, let me ask you a question. During your presentation, you mentioned that you were using temperature sensors to measure temperature in the space. But may I ask you, how many sensors did you use, and at what height, and for example, from what distance from the wall did you place them? Because whenever it comes to the temperature, it can really change depending on the place of the room, like that. And what kind of ventilation system did you use in those spaces?
Thank you for your question. Answer for this question is in 800 meters, quarter meters, we have some temperature sensors. They random placed in the big place, and if we have, for example, very high temperature, our system signalizes to our that it is in our work.
Okay.
Any other question? So I have one more question. Так, just a minute. Can you explain how the integration of chatbots with IoT system enhance the user experience for indoor temperature control compared to the traditional methods?
Thank you for the question. And if we have very high temperature, our system signalizes to us that is critical temperature. And we must to do something. System can open, for example, on or off the conditioner to stabilization temperature in hangar. And that is.
Thank you for your answers. Dear colleagues, any other question? No other question. Let's go to the next presentation, but I don't see the presenter 21. Let's try to swap the 21 and 22nd presentation. Just a minute.
Marina Yepifanova, and good afternoon, dear participants. I would like to present you my report on the topic climate factors and their role on the development of wind energy in the Lviv region. So, my content of the report. First of all, is a problem statement, analysis and research and publication, results and discussion, and finally conclusions. So, our problem statement. On Ukraine, one of Ukraine's strategic goals is achieve the maximum climate neutrality by 2050, in particular the energy sector. One of the main goals is the development of wind energy, increase in capacity by 140 gigawatt, and hydrogen energy. The Lviv region is a promising region of the development of wind energy in Ukraine, particularly due to its favorable geographical location. The main factors for the development of wind energy are climate factors, in particular wind direction and speed, as well as the vertical wind profile, which depends on the type of underlying surface. The purpose of study is to outline the role of climate factors in the selection of site for the construction of wind power in the Lviv regions. Analysis and research and publications. The issues of assessing the wind energy potential of the Lviv region under study was studied by research from Lviv National University, Ivano-Frankivsk National Technical University, Oil and Gas, and Ukrainian Research Hydrometeorological Institute. The papers analyzed wind energy research and the map the wind energy potential at different heights above its surface. So result and discussion. Lviv region is at the forefront of wind energy project in Western Ukraine. In 2024, wind farms with a total capacity of over 90 megawatt will be in operation in the region. It's a plan to build wind farms with a total capacity of over 300 megawatt. Important projects are also planned in the Zakarpattia region and the Rivne region. However, due to the significant complexity of environmental procedures, the projects are still at the planned state. Despite the Myrtle Law, one wind farm with the installed capacity near 55 megawatt, that's 10 wind turbine was built in Lviv region. They also planned to build at least 2 more wind farm with a total installed capacity of about 100 megawatt in 2024-2025. So about analyzing in the wind energy potential, a wind energy cadastre is complied as a zones system of wind regime parameters. The main parameters include the cadastre are mean wind speed, annual and daily wind flow, and others you can see in this slide. So the average annual wind speed in the Lviv region is 2.7 meters per second, and the average maximum wind speed is 3.7 meters per second. The highest wind speeds are observed in January and November, and the lowest in August. For wind energy objects in the Lviv region, as average annual wind speed at 50 and 100 meters were considered since the height of modern turbine operated in the higher range. According to the Global Wind Atlas, the average annual wind speed in the region varied from 4 meters per second in the Mavtin River valleys and 8 meters per second in the height of Mavtin ranges. The next slide, you can see two maps. First, you can see the map's wind speed in the Lviv region at 50 meters, and next you can see the main wind speed in the Lviv region at the 100 meters. It's based on the Global Wind Atlas, and the height ranges and typical for the ranges of the Skolivsky Skebovi Karpat in this part of Lviv region, and the upland of the Peret Karpatia and Podilska upland. You can see this orange and red markers in these maps, and the loss in the nearest tree and some values. The wind classes is an important factor in the design of the wind turbine. For example, if you place a wind turbine, its rated capacity at the wind class 3, the low wind, this turbine requires a larger rotors to capture the same amount of energy compared and similar to turbine as the wind class 2 manual wind. And wind class 2 and wind class 3 dominate the plants of the Lviv region. And with the development of wind energy, a significant drop in the air temperature provides a moisture front on the blades, and there is not wind, and leads to ice forming and icing. And during the period of operations, existing wind power plants in the Lviv region, no emergency related to blade icing have been recorded. And finally, I want to present some conclusions about climate factors that role in the development of wind energy in the Lviv region. First of all, the region has a favorable geographical location, and most areas are suitable for development in terms of average annual wind speed. At the same time, due to environmental constraints, a significant proportion of the territory cannot be used for wind energy, unfortunately. These include almost the entire mountains part of the region. For wind energy objects in the Lviv region, the average annual wind speed at 50 and 100 meter were considered, since the hearts of a modern turbine operated in the highest range. According to the Global Wind Atlas, the average annual wind speed in the region varies from 4 meters per second at the mountain river valley to 8 meters per second at the high on the mountain ranges. At present, there are not wind investment atlas that would help potential investor find sites of the construction of wind farm with a high wind potential and without violating environmental legislations. That's why it's the biggest issues for the wind energy and renewable energy, because we don't have any possibility to search in new areas, and we must know a lot of rules, legislations, our legislations, and a lot of information to search in new areas and new sites for the wind energy, for the future wind farm. So thank you for attention, and I'm very happy to present my topic and my report of for you. Thank you. Have a
And thank you for your presentation. I see Oleg. Do you have a question?
Yeah, I do. Yes, so speaking about your presentation, during your presentation, you mentioned that the global global wind atlas. However, here in Ukraine, there is an atlas of renewable energy sources developed by the Institute of Renewable Energy at the National Academy of Sciences of Ukraine. So there is also some data, and also there was a little interesting thing that some data that we have in meteorological here in Ukraine we have meteorological stations, and some of the data which we can use from our meteorological stations, they differ from what we can have from a global wind atlas. So have you tried to compare data on wind energy from different sources about Ukraine?
Thank you for the interesting question. Yes, we use different data from the Global Wind Atlas, from Institute of Renewable Energy, and in others. And for me, Global Wind Atlas is more interesting because I can use information for the local sites. For example, if I want to search some areas for the new wind power projects, I use this information from the Global Wind Atlas. And we have the information from the special wind information from the different companies who provide in Lviv region wind power plants. And when I want, I search this information, and I prepare this information. I see that it's not similar information, and Global Wind Atlas is truth information for the first information for investment in the project for the wind energy in Lviv region.
And here comes the second question after that. During your presentation, you mentioned how wind velocity were changing based on the height. But may I ask you, what wind velocity would you find to be economically sustainable to create a wind station at even at each height? Like, for example, what should be a wind speed to be at 50 meters and at 100 meters, so the produced wind energy station would be economically viable?
For our opinions, is better than the 100 meter, but really, if you see the Lviv region restriction maps and global restriction maps, we have a lot of interesting areas when we can provide wind energy, because it's a good good wind speed and in others parameters. But if in this territory we have a lot of restrictions, that's why in the region more than, I think, half but it's not good for the wind energy because we have a lot of restrictions. That's why when we suggest a new sites, we think a lot of factors, and after we want to provide this areas this wind plant in the future.
Actually, you didn't get my question. My question was a bit different. Let me explain. For example, there is a scene like, for example, there's theoretical potential of wind energy. Then there is geographical potential of wind energy. When we, for example, can exclude zones like slope of a mountain, like it's not possible currently to put it there. But there is also a scene known as technical potential. Sometimes the technical, or let's say also economical potential, is not calculated directly, and based on most recommendation, it's limited. Like it said, like we would think about implementation of our projects only in the zones where average annual wind speed isn't below, for example, 7 meters per second, like that. So of course, when it's high, when wind station is high, it's better for energy production. But what would be the minimal wind speed from your point of view, so that it will be so that we can produce at this place economically viable wind energy station?
Okay, the minimum is the 7 meters per second. It's the mountain areas, but we have a lot of restriction in this part. Example, it's the natural resources, it's protection areas, emerald network, and the others.
Okay, but speaking about, for example, what kind of well, whenever it comes to, it's not only restricted areas, like for example, like natural foundations, but what about, for example, the distances from road, distances from cities, distances from villages, and so on?
Okay, in our legislation, we don't have any norms and any distance. Only the distance from the citizens is 700 meters. But if we want to provide the new wind power plant in the protection areas, we cannot do it. And if we want to provide in the emerald network, we have a lot of restriction in this sites. That's why if you see Lviv region and mountain area and protection area, all Lviv region sites of mountain ranges is protection area and Lviv regions. That's why it's not good for the wind energy, unfortunately.
Okay, thank you very much for the answer.
Thank you.
Yes, one short question, please.
Can I?
Yes.
Thank you. When you calculate the energy of wind, you take into account velocity and temperature, but you don't take into account the humidity. Why?
Okay, I know that it's a good parameter and very important parameter, but unfortunately, we at that time when we provide this article, we don't have a good data for this parameter. That's why we cannot provide it.
And the next question is, your region is Karpat region, and in Karpat region, closely situated European countries, and do you have any project in cooperation in this field of the development of the wind power plant? In cooperation with European countries closely to Lviv region.
Nowadays, we don't have some projects, but I am not only the scientist, I provide the environmental impact assessment for the wind energy project in Lviv region, and in my portfolio is more than 5 projects. And I know another investor for this project, and now really we have a lot of projects in the region for the wind energy, and with total capacity more than 500 megawatt. And I believe in future more than less than 5 years they provide it in the region.
And what can you do? You have any information? The rate of installed the wind power unit for every day or every month in Lviv region?
Yes, but now this information is closed, unfortunately.
Thank you.
Dear colleagues, I'm very glad the participant got a second wind. It's really good. I see the author of 21st presenter, and we will return to it.
Hello, dear colleagues. I'm Irina Epifanova, and my author Vyacheslav Jejula, Vinnytsia National Technical University, and let me present you our results on the topic of increase in the energy efficiency of the biogas production process through vibration activation of heat and mass exchange processes in the bioreactor. So, in the course of anaerobic fermentation of biogas, in biomass, it is necessary to observe certain limits of temperature regimes. At the same time, the speed of movement of the substrate under the conditions of the optional fermentation process should not exceed the data of 0.7. The expansion of the development of biogas plants requires a reduction of their capital and operating costs. One of the important problems preventing the increase in energy efficiency of biogas reactors is the use of heating elements operating in the free convective mode of heat exchange. In addition to the large heat exchange areas and the correspondingly reduced useful volume of the reactor, the use of free convective heat exchanges leads to the formation of stagnation zones, stratification of the medium, hypercooling of the lower zones of the reactor, overheating of the upper zones. The method based on the vibration of the environment is the most suitable for the conditions of the biogas plant, since in addition to the intensification of heat transfer, additional mixing takes place. Also, among the most effective methods of increasing the intensity of heat exchange when liquid flows around borders is the vibration of the moment, which provides under optimal conditions. Also, the equation of motion of the activator plate can be found by solving the Lagrange equation. And having entered the coordinate system as shown in figure 1, we write down the kinematic relations between the components of the activator mechanism and the velocity equation, provided that instantiation center of the velocity is some point. Here you can see equations which we write down for describing the value of generate force of different works and the kinetic energy. And also we will solve the system using Röntgen-Kutta numerical method, and we obtain a solution in the form of values of the function. And using the solution of system 26, it is possible to determine the value of the speed of the activator plate. The liquid under the action of the plate also begins to take oscillatory moments and washes the heat exchange surface. A wall layer is located around the heat exchange surface, which heat transparent mainly due to thermal convectivity, figure 2. According to Fourier equation, we write that the heat can be determined by different equations, which you can see at this slide. Also, Based on the results of analysis of the developed mathematical model, it has been found that in the range of measurements, the obtained value of the increase in the coefficient of heat transfer from the horizontal heating tabular element to the water exceeds the value for free convection by the average of 1.5 to 2.8 times. Both medium fluctuations and heat flow have a significant influence on the intensification of heat exchange. Here you can see the laboratory where experiment was made, and also you can see figure 3, the surface of the influence of the Reynolds and Prandtl criteria on the value of the Nusselt criteria using vibration activation of heat exchange. So the law of motion of the activator plate has been found by solving Lagrange's differential equation. Based on the laws of thermal conductivity, convective heat and mass transfer, and convention of moment, a criterion equation has been developed that describes the heat exchange processes between the heating element of the substrate during oscillatory washing of the heater wall. Based on the results of the analysis of the influence in the fluid oscillation created by the moment of the activator plates on the intensity of heat transfer from the wetting wall to the water and the substrate, the choice of the determining temperature of the liquid and the temperature of the wall, which different methods of organizing convection is subtracted. It has been found that the oscillation of the medium by the activator plate intensifies the free convex heat transfer in the aqueous medium by 1.53 times. And thus, the use of the activator plate to intensity heat exchange in bioreactors allows thermostabilization and intensification of the biogas production processes and saves material resources by reducing the area of heat exchange devices. So thank you for your attention. My report is finished.
Thank you for your presentation, dear colleagues. Do you have any question? No question. I have some question. Can you explain how vibration activation enhance heat and mass exchange process in biogas reactors and the impact this has on overall energy efficiency?
Excuse me, can you repeat the question, please, one more time? Thank you.
Can you explain how vibration activation enhance heat and mass exchange process in biogas reactors and the impact this on overall energy efficiency?
Okay, I want to tell you that due to the process of mixing, it can be thermostabilization, and in this way, more gas is output, and I'm sorry, bacteria don't die, and also we don't have temperature, and also we don't have problems with temperature, and also due to mixing process, we have more organic. And this organic in this way will better. One second, please. And in this way, organic is better decomposes.
Okay, thank you for your answer. Could you discuss the practical implementation of your research for design and operation of biogas plants in Ukraine?
Okay, of course, I can tell you that we have a practical implementation in village Kanyushivka. So there is a farmer, and he has at his territory, we make this experiment, and also this farmer saw the better results and so he saw the better results in improving in yield, and also he saw thermostabilization. So he has the reactor for two meters, 2 cubic meters.
Thank you.
Thank you.
One short question, please. Sorry.
Thank you. You show that in your research we use the Lagrange model, Lagrange equations, but we show the one-dimensional Lagrange equations, and the experimental results and the reality necessary to use three-dimensional Lagrange equations with corresponding constraints, the borders of the active area of the reactors, of bioreactors. And instead of this, we use some coefficients in these equations. How you estimate the parameters of such equations? How we can explain the transition from three-dimensional Lagrange equations to one-dimensional one? Please.
One moment, please.
If you have some...
Okay, one moment, please. I'm sorry. In our one moment, please. The components of in our questions were general force and also kinetic energy.
If you have some troubles, you can try to answer in chat, and but
Okay.
now we move
Okay,
to the
okay,
next
okay, thank you.
presentation.
Okay,
Thank you
thank
for
you.
your answer, for your discussion, and
Thank you. I'm
move for
waiting for your answer.
move for the next.
Hello, my name is Paulo Shimanuk, and I would like to present to your attention a report on the topic calculation of electricity losses using neural networks for retrospective data with the presence of anomalous value. In the electricity market of Ukraine, distribution system operator and transmission system operator are required to purchase electricity to cover losses in their own network. This implies that the expenses associated with the purchase of electricity losses impact the final price of electricity consumers through the tariff of DSO and TSO. As of today, electricity losses of distribution network of Ukraine can reach 20%, while in the most European countries this loss indicator within the range of 4 to 6%. Additionally, sharp changes of the topology of electrical network lead to an increase in the forecast error of losses, and the single time series and reduce as a single time series and reduce the efficiency of network management. Considering the necessary of load forecasting, the idea of using the forecasting methods to determine electricity losses in electrical network has been proposed. In this regard, artificial neural networks are proposed as forecasting method, recognized as effective forecasting models. It is important that the presence of reliable load forecasting results in the nodes of the calculation scheme of different forecasting horizon. In addition, the reducing cost of the purchase of electrical energy allow to increase the efficiency of managing the model of electric network, in particular with the use of smart grid system, which is relevant for Ukrainian in modern condition. The realization of the set goal involved solving the following task, which you can see on this slide. Two approach to forecasting losses were developed to test the effectiveness of losses forecasting. First approach is forecasting the load of each node separately, followed by consolidation of data and the calculation of losses based on forecasted data. Second approach is calculation of electricity losses followed by subsequent forecasting of losses. For modeling the electrical network for loss calculations, the SEnW medium voltage network was used as the basis of the test power system. This system consists of the two transformers with the capacity of 40 megavolt amperes with 110 and 20 kilovolts, 15 nodes, 18 load sources with two sources removed to align with retrospective data, 14 lines including 12 cable lines and 1 overhead lines, and switch. All elements used in this network are elements of Panda Power library. Since this network is built on the basis of the real European network, it differs significantly in the term of load composition and network parameters of the Ukrainian network. Therefore, to ensure the functioning of the losses calculation algorithm, the calculation scheme was adapted to use the available retrospective data. The data for forecasting and calculation of electrical power losses, the data from the one of the Ukrainian DSO was used. The data of which includes 16 node load for the period from 2017 to 2019 with 30-minute discreteness. The total value of the data amounts to 48,048 values. After conducting preliminary data analysis, it was differently identified that the data contains missing value and anomalous value that significantly divided from normal values. To identify and replace missing values and anomalous value, our two-stage verification date algorithm was applied to use the dbScan clustering method, which is presented in this slide. The next slide presents the result of determining the losses of electricity using the different forecasting method. In figure 4 shows a graph of half-hourly losses per day using different forecasting methods. And figure 5 presents a graph of half-hourly losses for monthly period. The map function was used to assess the accuracy of presented approach. This slide shows that the forecasting errors of electricity losses. Having conducted forecasting and losses calculation using all approach, we observe that generally all forecasting with subsequent losses calculation method have a lower error in losses. It is also worth nothing that the use of data analyze method for detecting and replacing anomalous value allow for an improvement in forecasting result. The obtained research result are component of the data preparation work of the smart grid model of operational management of distributional network based on artificial intelligence methods. This model is being developed by the author of the publication with the framework in the joint Ukrainian-Lithuanian project. In 24-25, the result of the study demonstrates that the proposed method for short-term forecasting of aggregated electricity losses value in the power grid based on retrospective data using deep learning artificial neural network allow to increase accuracy in determining losses without performing the calculation compared to existing method. Additionally, methods of the short-term forecasting of the node load based on the deep learning artificial neural network have been proposed. This allows for an increased accuracy in determining and calculated values of losses in the power grid by incorporating forecasting node load values during the calculation. The result of forecasting electricity losses show that the application of the data verification method and forecasting methods allow to reduce the magnitude of losses compared to forecasting actual losses data with the expecting anomalous value. Conducting additional data analysis to identify and replace anomalous value has improved the accuracy of forecast for both node load and electricity losses. For the forecasting error of losses using artificial neural network allow obtaining a MAP error within 3.29% for the forecasted verified data of the node load used of loss calculation. Then the forecast of verified loss losses data have an error of 20.24%. The loss of the unverified data is 20.08%. The use of forecasting methods is most effectively demonstrates that when predicting verified data, not lower data use for loss calculation. Based on this presented result, in future studies, it is planned to improve the methods of forecasting and calculation of electricity losses, in particular with the possibility of using additional factors. In addition to obtain more accuracy value of the losses, it is necessary to build on test network based on real scheme of electrical network. For that moment, I am done. Thank you for your attention.
Thank you for your presentation. Yeah, Tri, welcome.
Thank you. My first question is, what kind of neural networks we use in your investigation?
In that research, we used LSTM neural network. It's a long short-term memory neural network.
Talking about the short period, what does it mean? It means some hours or a day or a week or a month? What does it mean short period, forecasting period?
It's mean from 1 hour to 24 hours.
24 hours. For 24 hours, temperature, traditionally we consider the electricity network in the open air. In open air, the temperature significantly influence on the resistance of the lines, and of course increase or decrease the losses in the electricity in the network line, in the high voltage lines. And when we forecast using only the data, the losses of data in the previous period, and don't take into account the temperature or humidity of the air, and during the year, the temperature must be changed from 10 to 20 degrees, and it's significantly influence on the losses. And without looking at this, you get estimate the errors on 3%. It looks strange. How you can explain it?
I think that we get that result because we use the method of analyze data and clean this data about anomalous value and some zero values, or which can
No, it's traditionally approach to prepare the data for investigation. So, but we use only the data of losses of power in electricity, the measurement data. Is it no?
I'm not sure, because we calculate the losses, and then we at that result, at that data, we forecast that electricity losses, and then calculate them with actual with actual losses, which we calculate.
How about the temperature or humidity of the air that dramatically increase or decrease the losses in the lines.
And that research we don't add information about temperature and how it could could influence to the result of forecasting and to result of losses. But in future research, we try to get that information.
And how we can explain the accuracy? You estimate the error only on 3% without looking at taking into you neglect the influence on the parameters of the error.
Maybe it's testing testing values which we use, or I don't know. We could try to take the other test part, and maybe it could get another result. I don't know.
Thank you.
Dear colleagues, thank you for the discussion. We must move to the next. One short question.
One short question. What kind of mathematical models do you use in your research? Because it's statistical models, deterministic models. Because I haven't seen any mathematical equation or relation in your presentation. We use I guess statistical method. Pardon, what method? I didn't hear. Thank
you. You can try to answer in chat because we must move to the next presentation.
Thank you.
Dear colleagues, let me introduce myself. My name is Roman Valyansky, and I represent Igor Sikorsky, Kyiv Polytechnic Institute. The topic of my speech is variable structure controller design for electric drives with variable torque load. And this speech is devoted to design and study of energy-efficient control system for electric drive of various turbo machines. You can see the problems which we raise and solve in our paper in slide 2. One can group these problems for better understanding in 3 types: analysis, simulating and modeling, and control system design. It's necessary to say that modern turbo machines are big industrial complexes which consumes a huge amount of energy in indoor and outdoor application, where they are used as pumps, ventilators, compressors, and so on to provide various industrial processes with raw materials, various gases, and liquids. Due to their big consuming power, it's very important to design energy-efficient control system for such machines. Also, because of physical principles which are based for these machines, from mathematical viewpoint, one can consider them as a complex nonlinear dynamical system which can lose their stability under some condition. Unstable motion in turbomachines cause their technical damage and can lead to catastrophic consequence for the plants and factories. That is why the problem of control system design for such devices is a very important problem. We offer to solve this problem by using control theory approaches and methods. To apply them, at first we define the model for the considered electric drive. The main part of this model is a nonlinear function, which defines ventilator torque. This torque doesn't have a strong mathematical description because of it depends on the operating condition. This condition allows us to define this function as some power function with non-integer power in the most general case. We use this function to write down motion equation for the considered electric drive. This equation can be rewritten in various forms to use them in various applications. We rewrite this equation in our paper in dimensionless form because of the using dimensionless state variables which are given here in this equation. Besides of uncertainty, nonlinearity of the considered dynamical system, it also characterizes that by parameters variation during electric drive operations. In general, it caused by temperature influence as well as voltage variations near powerful consumer. We offer to take into account these variations by considering some intervals which define possible values of drive parameters instead of exact ones. Also, we use interval methods to define intervals of possible values for ventilator torque, which is given here in slide 7. To have possibility to use linear control theory method, we use piecewise linear intervals to define boundaries for this nonlinear function. Parameters of this piecewise linear function can be defined as a solution of following optimization problem. And you can see solution of this problem here in slide 8. Here you can see quite rough solution of this problem. And this solution can be clarified in real application without breaking of integrity usage of the proposed approach. Here in slide 9, you can see the usage of this piecewise linear function, which we define and rewrite into interval form to define following interval differential equation, which we use to define dynamic of the considered electric drive. This differential equation have linear form, but it has piecewise linear terms and coefficients. We offer to design the controller for considered electric drive by solving inverse dynamic problem. We solve this problem by using transfer function apparatus, which is the most used approach in control theory. To define this transfer function, we use following interval equation, and we offer to generalize this transfer function by considering generalized inputs, which takes into account not only input signals, but also some initial condition. You can see such matrix transfer function here in slide 11. As you can see, this transfer function is interval and matrix differential operator, which take into account some initial condition which are defined during electric drive operation. In slide 12, you can see simulation result for the considered electric drive. Here we study the processes of start with drive, its steady state mode, and stop of this electric drive. It's clear that the proposed approach, which is based on the use of interval methods, allows us to define trajectories which are bound real motion of the considered electric drive. To design the control system for the considered electric drive, at first we define the desired transfer function, and then we solve so-called inverse dynamic problem and define following transfer function which define dynamic of the designed controller. Since solution of inverse dynamic problem is based on the use of transfer function for the considered electric drive. Here in transfer function of controller, we also get differential operator, which is piecewise linear and which is defined as some matrix operator which take into account initial condition of the plant, which take into account some initial external signals, and also which take into account electric drive parameters as well as parameters of the desired transfer function. It is correct for any branches of this controller. Here in slide 15, you can see the simulation result for the designed control system. It's clear that the designed control system is quite precise. We can see that control error here is much less than 1%. Thus, we can claim that motion trajectory is formed with high accuracy. This trajectory is formed by applying following voltage for the considered electric drive. It's necessary to say that the similar results can be achieved if one apply for the considered electric drive sliding mode control. You can see simulation results which are similar for the previous one. But if one starts to compare energy consumption in both of these systems, he can find that sliding mode control consume much more energy than the proposed one. It can be explained by using continuous control signal instead of discontinuous one. And you can see the conclusion. about our work here in slide 18. The main of them is a proven possibility to achieve the control performance, which is similar to sliding mode control, but it have the reduced energy consumption. Also, it becomes possible because of the use the developed mathematical apparatus which based on the interval methods instead of sliding mode control. And thank you for attention.
Thank you for your presentation, dear colleagues. Do you have any question? Yes, we are welcome.
Thank you. My questions link with the mathematical description of the process we used. When you're talking about the piecewise function, this function is continuously first order or have a gap in the some fixed point.
We are continuous one.
Continuous, but have a gap as a first differential.
Yes.
Yes, and the second question linking with this, we use Laplace transformation in order to get a solution of the differential equations, but we have the system of linear first order differential equations, and these equations we can get solution without using Laplace transformation. Why you need to use Laplace transformation?
Yes, we use Laplace transformation to use control methods and use so-called transfer function, which is based on the Laplace transformation. It's some I don't know, representation of plant description, plant dynamic and controller dynamic too.
It means that it's simply comfortable form, mathematical form.
Yes.
Only.
Yes.
And it's necessary to use Laplace transformation in this investigation. You can get solutions directly.
Yes.
Your solutions is the piece of function, and each function is exponential function. A piece of function is exponential form. Yes.
I think if we apply our controllers, yes, it will have an exponential dynamic, but with other controllers or without controllers, this dynamic can be, for example, harmonic or so on.
Thank you.
Dear colleagues, any other questions, comments? Thank you for your presentation. And the last presentation for our workshop, we don't have the video recording. And Rasul, I see you. You can get the presentation. Microphone.
I heard myself. Volodymyr, I have to myself.
Yes. We don't have your recording.
Yeah, really?
Really, you
Wow.
sent You sent
Oh,
us
I didn't
another
thought that.
file.
I just minute them. I shall find it in my computer now. Ah, maybe in program. It's in program.
Yes, you sent us another file, not video presentation.
Oh, so just minute. У нас нету выбора. Нет презентации? Да. А где оно? Не помню, куда я его дел. А где-то я это его делал.
If you can find the video, you can share the presentation and talk in live.
Yeah, I try to leave it present, make some presentation. Just minute, please. Just minute, please. So. Oh, it's visible?
Yeah.
Unfortunately, it's I have to maybe to make here slideshow.
Try.
So?
Yeah, it's good.
Oh. Good afternoon, everybody, my colleagues. We propose you some presentation called Determination of Operation Parameters of Accumulative Electric Heating Systems. Here is also me, of course, and main also is Anatoly colleagues. We are from National University, Poltava Polytechnic. So, a significant number of challenges in the field of sustainable energy and heating system can be overcome with the help of buffer storage of thermal accumulators. Because, why? They are as essential elements of efficient district heating systems. So, included in the heating system with renewable and alternative energy sources. They are used in heating system with solid fuel boilers and pronounced as cyclical operations to enable interrupted operation for solid fuel system boilers without overheating. And used in the system with electric boilers, it is possible to use different tariff of system and multi-tariff systems. In this case, it's become possible to accumulate thermal energy during the period of the using potential high tariff and minimize the consumption of electrical energy during the daytime. During periods of aggressive military operation and attacks on the Ukrainian energy sectors, batteries provide the opportunity to increase the stability and reliability of the heat supply system and reduce the risk of water freezing in the system, of course, in winter time. In Ukraine, it's extra. In addition, the use of electrical energy for heating, building, and high can be held level of out of an inverse of electrical energy consumption in the power supply system in conditions of storage generation capacity. We have conducted research on the option of using batteries in an electrical storage heating system. But this does not exclude the possibility of use the obtained dependence of the other variants of the use of thermal accumulations. In our studies, water or an aqueous solution of ethylene glycol was used as a heat storage battery without a path of transition of the working fluid and chemical transformations. The main objective of the work was a assess of equivalent characteristics of calculating an electric storage systems. Characteristic feature of which is the following. Significant unevenness of energy supply under the condition of application of two-rate tariffs of electrical energy. The need to comply with standardized microclimate parameters in the heating rooms in conditions of changing outdoor air parameters, and thus the potential presence in the heat supply systems of buildings or premises in which it's possible to partially or completely reduce the amount of heat used for heating during the period of supply and accumulation of energy. For example, do the accumulation of heat in building our envelopes, or a temporary decrease in temperature in room. The development of the mathematical models was based on the following schematic diagrams of the system arrangement. Here is shown systems, schematic systems, what included, for example, water storage tanks and transformations coolant to living home premises, and explain it what is included in the scheme. The thermal model of obtaining quantitative characteristics of the system was based on the heat balance equation in heated buildings. The following are accepted as the main quantitative characteristics obtained in the work. At first, required absolute power of the energy generator in kilowatt, of course. The required relative powers of the energy generator as the value of ratio of the absolute power to the value of the mean of thermal energy for heating, volume of the heat accumulation tank and the required water in measurable water in it, relative volume of water in the tank as a ratio of the material of the water in the calculated coolant flow in the heating systems. The introduction of relative indicator made it possible to obtain universal recommendations for determining the quantitative characteristics of heating system for arbitrary thermal power. One of the factors of obtaining the calculated dependence was the required temperature of the coolant, which will be obtained during the extraction of heat from the tank and necessary to ensure standardized microclimate parameters in the room. We have given equation for calculating it. The research also took into account the efficiency factor of the thermal insulation, the storage as. Take into account the above. The results obtained in the universal dependence of determining the required power of the energy generator in the storage heating system. We have calculated or given some formula to calculate it. Of course, explained which of parameters included into this formula. So, and graphical dependence were obtained to determine the quantitative characteristic of storage heating system. At first, to determine the relative power of the energy generator, and to determine the relative capacity of the battery tank. The obtained dependencies were tested under the operating system of the heating system. As you know, here is shown some storage capacity for heating system with estimated heat determined, for example, for 250 kilowatt. It really it's working now in the town, maybe Mirgorod. There is resort. In one of the building, there is tested it for as an alternative possible to supply the heating in the building. And as a conclusion, I have to tell about the use of accumulator heating system. When using electrical energy, makes it possible to realize the advantages for two-way tariffs of electrical energy, and ensures the reduction of the cost of heating while complying the standardized microclimate parameters in the premises. And the capacity of batteries in the electric heating system is greater compared with the use of other systems. For example, with solid fuel boilers or renewable and low potential energy sources can be used also comparing with hard fuel, for example, wood. And thus, the use of electrical energy for heating buildings at night using heating accumulators can be a good way to level out the uneven consumption electrical energy in the power supply system in conditions of shortage generation capacity. Their proposed methodology for determining the quantitative characteristics of population heating system can be used not only when using electrical energy, but also for other energy options also. One of the conditions of the successful implementation of accumulation heating system is to reduce the heat demand of buildings for heating and thermal modernization of buildings to a level that meets modern thermal protection requirements. Thank for your attention. We are
Thank you for your presentation.
Oh,
dear colleagues, do you have any question?
I do have a question, sorry. May I ask?
Welcome.
Okay, so I have questions. In your calculation, you only paid attention to what is usually called in some literature as tank thermal energy storage. Like you have a tank with water in it, and it was designed to fulfill the annual heating consumption, like that. But in the recent time, there is a really big trend in Europe to develop high temperature thermal energy storages. Like, for example, maybe you have read, of course, some sort of marketing, but still, about using, for example, sand-based solutions. Like, while sand has a lower capacity than water, at the same time we can heat it up to the rather high temperature, and thanks to that it would take less volume to have the same amount of heat. Have you looked through such solutions?
You know, we are researching only giving some opportunity to pupils to have some possibility by other way for heating systems. We are not giving some opportunity to have some heat water. in for showering, for example, for bedroom, only for heating system to have some temperature in living room. And we calculated only by basic, taking it to M only this way.
Okay, and may I also add that actually it's just one of the field of my research is thermal energy storage, and one of such thermal energy storage, since there are since known as storage heaters, and for example electrical storage, electrical flow heating. Have you compared your design? Well, I understand those are differences, but for example, the cost of your design with other possible solutions, like for example, like local heating.
No, we compared not with other possibility to heat directly, use electrical in living room, for example, yeah, through the electrical current. No, we are giving possibility to living room together as a society, for example, for OSBB, yeah, it only by city. But we have in Poltava, we are from Poltava, in Poltava, there is also one man with his own house. He organized it, storage tank, and used for wood fuel, gas fuel, and electric fuel. In one house, about his house is not so large, not so big, about up to 200 square meters. 4 person is living in his house, and about 15 or 16 cubic meter is power for this tank. But there is possible to heat it electrical currently and by gas, by wood also. There is a little bit pipelines and one pump for heating system. It's private. It's possibility for any families to have some heating in his. Maybe in future, after war time, it will be actual for Ukraine, any home also.
And also one more question. During your presentation, you mentioned two-zone tariff for electrical energy. And have you looked through the possible usage of a smart grids, where the tariff for electrical energy isn't static by time, but is dynamic like that? Like how can that help?
You know, we researched it only for we are now on starting to use it, to research it, but for large possibility, maybe there is one disadvantages. Heating storage, heating tank should be very large. It's sometimes in when we will tell about multi-storage house, there have to be another, maybe close this house, specialized room where we have to install this system. It's disadvantage. But maybe in the future, as continue researching, we will find out some solution for this question also.
Okay, thank you very much for answers.
Thank you for questions.
Dear colleagues, any other question, comments? Thank you so much, Russell, for your presentation.
Thank you for you also.
It was the last presentation of our workshop for today. So I want to say Thank you for all colleagues, all conference participants. Thank you for your active participation and valuable contribution during our event. You dedicate to science and innovation is key to our collective success. We hope you gained new insights and left feeling inspired. And so maybe who want to tell us some comments, welcome. If nobody, yeah, I welcome.
I think I'm not Ukrainian. You know, I'm from Caucasus, but long time I'm living in Poltava. About more than 50 years, I like Ukraine. I know Ukraine have very good energy, and all I am sure Ukraine will be win in this war. Glory to Ukraine.
Героям слава. I hope next year I will look of us and more participants in good health.
Okay, good. Oh, everyone. Good health. Bye.